So, good morning, everyone. Welcome to the morning session of the fourth day of our FDP. Today, we have our speaker, Dr. Debrata Viswas, and Dr. Sanjay Kumar will moderate his session. So, Dr. Sanjay, sir, please
Thank
take your
you,
charge.
Vishal sir. First of all, good morning, everyone. On behalf of Amity School of Engineering and Technology, Amity University, Patna, it is a great pleasure for me to introduce our speaker, Dr. Devbhat Biswas. He is the Assistant Professor of Physics at Department of Physics, Bankura University. Since 2019, he has served the same at Rampurhat College since 2017. Dr. Biswas obtained his master's degree with radio physics and electronics as a special paper from Bardhaman University. He obtained his PhD degree from Bardhaman University on nonlinear dynamics. He is author of 22 research articles, which is published in International Journal of High Reputes like Physical Review E, EOS, Nonlinear Dynamics, IJPC, and European Journals of Physics plus etc. He has written a book which is published in Springwell. He has traveled foreign for research purpose. Now we are going to start our technical session. So I invite Dr. Vishwas sir. Please start. The platform is yours. Hello.
Okay, thank you, Sanjay sir, for the nice introduction, and thank you, Vishal, for inviting me for the talk. So, let me start. Is my screen visible?
No, sir. No, sir.
No, no, no.
Okay, I have to share. Now, probably it is visible.
Yes.
Yes. Okay. 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 So, my today's talk is LaTeX, the ultimate word processor, and I am Dr. Deobroto Bishwas, Assistant Professor of Physics at Bankura University, West Bengal. A historical review, we can say that the father of LaTeX was Leslie Lamport. He started building it in 1980s. How he created it? He needed some right take macros for his own use and thought that with a little extra effort he could make a general package usable by others. Then Peter Gordon, an editor at Edition Wesley, convinced him to write a LaTeX user manual for publication. Meanwhile, Lamport released versions of LaTeX macros in 1984 and 85. The LaTeX 3 team was formed in 1994 and released LaTeX 2E, the current standard version. So this is the historical review, and Leslie Lamport is the father of today's LaTeX. Typesetting system in LaTeX. What is the typesetting philosophy? The philosophy is separating presentation from content so that author can focus on the content, what they are writing, without attending simultaneously to its visual appearance. In preparing LaTeX document, the author specifies the logical structure using simple familiar concepts such as chapter, section, table, figure, etc., which we shall come in elaborate, and lets the LaTeX system handle the formatting and layout of these structures. The LaTeX system is a markup language and handles typesetting and rendering. Advantages of LaTeX. What are the advantages of LaTeX? That is, it is dealing with mathematical notation. It is the finest software to deal with mathematical notations and equations. Beautiful typeset outputs, structured files, management of internal references, management of citations, customizations, user-friendly, commonly used, and easily converted file. These are the advantages of LaTeX. Now, next question comes how to install. Then you may have different operating systems in your computers. Then you have to follow different paths. If you have Windows, then just go to the Linux website, and from there download from the Windows. Here you can download the package, full package from this portion. Download, extract it, double click it, and it will get installed in your Windows machine. If you use Linux, then you have to go to command prompt, that is terminal, and then you have to type sudo apt update and sudo apt upgrade, then sudo apt install take live latex extra, and hyphen y means it is yes. And after installation you can check the version by latex double hyphen version. Another way is to install the synaptic package manager. Here I am showing you, this is the synaptic package manager. Give your password, and some other package is using it, so you can get it from the synaptic package manager also, where you have to select the take live package and mark it and apply it. So after that you can work with the latex and latex software in your computer. There are different easily available latex editors, of which some are very famous. One is TechMaker, second is LYX, third is Technic Center, fourth is Tech Studio, and nowadays one of the most favorite and collaborative LaTeX editors is the Overleaf. Here you can create your account and make different projects, and from those projects you can just share to your collaborators, and simultaneously they can edit or they can do anything they want with the document, with the writing, etc. So these are the editors. I am showing you the TechMaker I have installed. Sorry, I don't have TechMaker installed in my laptop because I don't use it actually. I use the general gedit and terminal. I am coming to that. So gedit along with terminal we shall be using in the class. So this is the window of gedit and this is the window of terminal. How to create a LaTeX document? First, we shall open a gedit, then write and save it with a file name .tex extension. Then open a terminal, run the following commands. The commands are LaTeX, then space, then file name, which file name we have given to .tex file. So after entering this in terminal at the directory which the .tex file have been saved, it will create a .dvi file. This is a document file, but we don't want .dvi file. We want ultimately PDF file. But before that, we have to go another step. That is, we shall convert the DVI file to PS file. So this is done with this command dvi ps -o filename.ps and then file name dot dvi. Then we shall be converting the ps to pdf file, and for that the command is ps to pdf file name dot ps and file name dot pdf. You may exclude this last part, that means file name dot pdf. If you give file name dot ps, it will create a pdf file with same name file name dot pdf. This part may be given when the file name you want is changed. So these are the three basic commands we will be using, and there is another command, that is bibtex command for uh, referencing. I shall be showing you shortly. Okay, now let's start. So first of all, I am creating, this is my home folder. I am creating a folder, suppose called LaTeX. This folder has been created. Now I am opening gedit. This is gedit text editor, and this has been open. Suppose move it. Now I am creating a new file and saving it at the LaTeX position. Suppose this is entitled as met underscore latex dot tex. Just enter it and it will save here. So you can see that met latex dot tex has been saved, and it is a just empty text format. First of all, we have to give some comments or give some preambles to use the LaTeX. The preambles are backslash. The packages, the other things starts in LaTeX with a backslash. So backslash, we have to first provide document class, and with a second bracket or braces, just save it. This type of the document we are creating article. So this one is saved. Now we have to give some more options to LaTeX. So the font size is 12 pt. Next next we can give the paper size, that is A4 paper, and one side. It will print in single side. So this is the main part, and this is the document class. I have assigned it article. It may be report. Suppose report, or book, or letter, etc. So these may be, and if we want commenting, then we have to use a percentage sign that makes it a comment. That means the LaTeX interpreter will not consider this as its comment. It is just readable by the user. And to start with, we have to give two comments, just begin document and end document. So with these commands, we can write the article inside begin document and end document. Here we shall be writing. Now we have to open the terminal. I am opening the terminal and navigating to the LaTeX folder, LaTeX, and checking what is there. There is met latex.tex. Now I am just running the command as you seen here, that is LaTeX file name. Here file name is met underscore latex. LaTeX met. I am just removing .tex. It don't need. So Here undefined control sequence, here it is showing undefined because I have done some typing mistake. So document class, the O was missing. I am just quitting it, and you can see that a log file has been created and an aux auxiliary file has been created because we have written nothing here. Suppose I am wanting to give the title of the document, then I have to give it before the begin document and end document. Title, suppose I am giving the title name, what I have used here, title, the LaTeX processor, I am giving it here, and author, suppose my name, I am giving backslash author, and the date will be given automatically. Okay, now I am running it, but yet nothing is appearing because I have not given the LaTeX the instruction to print these in my article. That must be given inside the document class. So I am giving it make title and second bracket. The grouping in LaTeX is done by second bracket. If you give second bracket, it will try to group things. So after that, I am just running it, and you can see here an amity latex.dvi file has been created, and it is showing nothing. It may show nothing because the dvl files sometimes shows some problems. So we shall convert it to dvi to ps with this command. So dvi ps hyphen o met.ps and met.dvi. So you can see that a ps file has been created here, and after that we shall convert it to pdf file. This is the classical way, ps to pdf, met.ps. I am not giving any pdf. So here you can see that met.pdf has been created, and you can see page 1 has been created with the LaTeX document processor. Suppose here no space has been provided. So if you want to provide any space, so you may give the tilde here. So I am running then LaTeX, then dvips, then ps to pdf, and you can see that there is a space, the LaTeX document processor, my name, and by default the date has been July 27, 2023. If you want to remove it, then you have to give some date and empty braces after this. So if you provide this, you can see that again you run LaTeX. Whenever you change the document, you have to run LaTeX. That will make the dvi file, then you have to convert dvi to uh, ps, then you have to convert ps to pdf. Now I am running this and running this. Here you can see the date is omitted. Okay, now I want to start some sections, and it just creates the section automatically by the comment section, and you can get it here. You can create abstract here, etc. Suppose I am giving a section called introduction. Okay, now if this is created, now run it. You can see that it has taken the number 1 and introduction in bold font. If you want to create some bold font or italics font, I am coming to there, and just write whatever you want here. I am just copying that, this portion I am copying, and I am just pasting it here. So I have some things copied. Now just run it, that is LaTeX command, then dvips command, then ps to pdf command, and you can see that the suite justified with a great font has been created as the introduction. Now it has the space, the geometry, you can change it. I am coming to that. Suppose before introduction you want the abstract, then we can create it by begin abstract and end abstract. So I am just copying that portion also, the abstract portion, inside the begin abstract and end abstract, and writing it. Now running the LaTeX, the DVIPS and the PS2 PDF. You can see that the abstract portion has been created by itself with abstract word at the center, and this whole text format at the center but justified, that is less than this justified portion. So you don't have to get tensed, or you don't have to think about the formatting of the document. That will be taken care by the LaTeX itself. You just have to give some command and make the LaTeX understand, and you have to just write. Now suppose I want this multi-stability or the first some words to get italics font, then we have to give it second bracket and give the backslash and emph emphasize, and I am going up to this portion. So multi-stability is an interesting and intriguing. Up to that portion I am just emphasized or given it italic form. So run LaTeX, then dvips, then ps2 pdf, and you can see that, sorry, give it outside, then it will be useful. And you can see that multi-stability is an interesting and intriguing, that has been written, you can see that has been written in italics. Now suppose you want to give this portion multi-stability reveals in many forms to bold font, then you have to give bf means bold form, and then complete the brushes, then you have to run the 3, and you can see that, sorry, this portion have to be given inside the brushes. So emph outside brushes and bf inside brushes, otherwise it makes the whole thing bold font. Hmm. Here you can see the multi stability reveals in many forms. So in this way you can just make your document more suitable. Now I am coming to the next part, that is the most important part, and that is the equation part. Suppose I am just wanting to refer this introduction section, then I have to give a label to this section, suppose sec intro. We can refer this section by this keyword anywhere. Suppose I am creating another section that is called, suppose, mathematical model, and in this section I am writing as we have seen from section, this is giving the space, and ref give these keywords. I'm giving it here, dot dot dot. Then if we run the LaTeX and convert it to PDF, then we can get that number 2 has been taken automatically, and mathematical model, it has been bold fonted automatically. You don't have to do it. You have to give just section command, and that will make this bold font. And you can see that as we have seen from section 1, I didn't give section 1 here. I just given the keyword of the label into the ref command. So the ref command, backslash ref command, references the keyword where it is. So this is the mathematical model from section 1. Now I am coming to some other forms. Suppose I am copying this portion and writing it. The system equation reads the form, etc. Suppose you give. If you want to write some equation, then you have to start it with begin equation and end equation. Then you have to write some equation. Suppose a plus b is equal to a square plus 2ab plus b square. A plus b square is given by this cap square is equal to a square plus 2ab plus b square. Suppose comma, and just run it. I shall suggest you to run the LaTeX twice. It will uh, produce the references or the reference which you are calling better. So you can see that the mathematical formulation has been taken in a very well manner by LaTeX itself. A plus b whole square is equal to a square plus 2ab plus b square comma, and the mathematical equation number has been taken automatically. Whatever you type here, what equation you type here, the mathematical number will be created automatically. You can refer to this. For reference, you have to create a label, suppose EQ. Okay, now we can give this. I am copying, not writing to save the time, where this is called the inline mathematics command. If you want to write the mathematical equation inside a line, then you have to provide $2. Inside $2, you can write anything, and that will be printed in line. Okay, so this is the inline equation operator. So where a and b in, it produces a sign that is in, and mathcal is a format of word. Mathcal r means it will create a converted version of r, which will be seen here. And we are writing from equation. Suppose I am wanting to refer equation 1, then I have to just use backslash eqref and inside braces eq, that is this labeling I have just used. So here it will come from equation 1 we get, etc. This double backslash I am removing now. I will come to it in just now. Run LaTeX twice. Okay, this, there is some error is arising. What is the error? Undefined control sequence. You have to learn to read the errors here. Undefined control sequence, and that is mathcal. It cannot find what is mathcal. So we have to use some package which will tell it the mathcal. So after document class, we shall use the package with use package command ams math and ams sim, these two packages. AMS, American Mathematical Society Math, and AMS symbol. So if I use these two packets and run the LaTeX again, then no error is coming. Twice I run it and then convert to PS and PDF. So here you can see that the equation is printed here, and where A and B in, this is called in, this portion is in, and mathcal, here you can see the converted R, that is real. From equation 1, I didn't give any number here, but just given the labeling and referred it as EQREF. EQREF means equation ref. So we get this. Okay. So in this way, we can refer to any section or any equations or any figure or any table, anything else I shall be coming. Now, I am providing some more complicated equation. Suppose I am giving some more complicated equation. If you give an extra enter, then it will create a new para. Okay, let's check what happens. It has created a new para with no spacing. But if you give a double spacing, then a double backslash after the previous para, then it will create some spacing here. See that sum has been downward. Some more complicated equations here. So how to create equation? Begin equation and end equation. Inside that you have to write that equation. I am writing that, suppose I want d2x dt2 is equal to some other things. So I am giving it a frac command. A for AC means fraction. This is numerator and this is denominator. And I am writing d2x dt2. Suppose I want to check what happens here. Now just run it thrice and you can check that d2x dt1, I have given here dt1, make it dt2. So the frac command creates a fraction and run it. So d2x dt2. Now I am writing, suppose something plus backslash sign, it will create a sign. Okay. And x square frac dx dt plus, suppose, plus cos omega x, suppose cos omega x, cos. If you want to use the Greek symbol, you have to just write backslash omega x is equal to, suppose, e to the power x square. Okay. So after writing this and just running this, converting this to PDF, we can see that d2x dt2 plus sine x square dx dt plus cos omega x and e to the power, here something occurred that the left braces has been parenthesis in the upper, so we have to group it, just group it. I am grouping it by second brackets or braces. Run it. You can see that the x square has been in the upper side. You can leave the parenthesis here. I am leaving the parenthesis. and the fine e to the power x square. In this way, you can type any equation, any differential or any other things of equation. I am going to some more complicated. This may be labeled as diff eq. Give it the label diff eq, and some more complicated form. Before that, I am going to give what are the omega etc the parameters. So where x in mathcal r and omega in mathcal r to the power plus, that means real and positive. So after running this, you can just see a next page has been created. So where x is in r and omega in r plus is written. Now I am coming to some more complicated mathematical equations, that is Schrodinger equation. More complicated Schrodinger equation, you can give two dots inside O, but I am not coming to there. You just use this, will make the O two dots, and start it begin equation and end it with end equation. Give a label sch equal whatever the label word you can give. Now I am giving I h bar, that means I h cross, and frac partial means del psi xt partial t, this is in the left side, is equal to minus frac h bar square, that is in the upper h cross square divided by twice m, and frac partial square psi xt partial x square means x2 v of xt and psi xt. So you just run it, and the beautiful Schrodinger equation comes here with the formatting. Okay, so in this way we can write any different difficult formulation in LaTeX with this ease. You don't have to worry about the position, you don't have to worry about the numbering. If you include any equation before 2 and 3, that equation will be given number 3, and automatically that will make this 3 to 4. Okay, so these are automatic in LaTeX. Now inline equations I have discussed a little earlier. So inline equations can be put with insertion of these two. I have given the backslash because I want to print it. So whenever I want to give the equation, suppose frac d d2x dt2 is equal to minus kx inside a line, so I have to write it inside $2 signs. Now run it, and you can check that the inline equation has been created. Uh, Vishal, how much time I have?
Yeah, you have time.
Okay, okay,
Yes.
okay, okay. Thank you.
According to you,
Sorry. So this is the inline equation. Now, if you want to type the equation without numbering in the middle of the page, then you have to give $4 signs and write it inside $2. Suppose I am giving equation in the center without equation number, make it number, maybe put through $4 signs, and inside $2 signs you can give your equation. So I am just running it and converting it to PDF, that I have not stated it begin equation and end equation, but given $2 in each sides. That is making the equation this like equation 3 or something other equations. but the numbering has not been given. If you want to skip some numbering, then you have to write it inside $4 signs. Okay. Okay. Next, I am coming to sub equations. If you want several equations to be written inside one equation number, that is, you want to give equation 4a, equation 4b, equation 4c, etc. at a place, then you have to use these commands. I am writing it just sub equations, and it is a subsection. Okay, you can see it here. I have created subsections, means that sub equation title will be a part of this section. Equation 2, under under section 2, it will be created a subsection. So just run it, and it will be probably 2.1. You can see it. It is 2.1, means it is a subsection, and the heading of the subsection is sub equation. The sub equation contains a number of equations arranged in one place with numbering 4a, 4b, etc. So how to use it? Just give begin sub equations and end it with sub equations. Okay. Now, if you want to align it, then you have to give another uh, command, but I am coming to that later. Suppose I am giving here the equation dot x is equal to some function of x comma y plus d of d into y minus x. Just run it, giving only one equations. Okay, dot x sub equations. Let me check what happened. Oh, sorry. Dot x. Some typing error there may be. The same error is coming, and here no equation has been created because I have not given any align option. So I am writing begin align. This will align the equation, and end align. So to align the equations, you have to given the ampersand. Whenever you provide the ampersand, it will align those parts uh, in the below. So I am giving the ampersand, only a single ampersand before the equal sign. The equal sign in the equations will be arranged in a vertical line. Okay, so dot x is equal to this. Now run this. There is no error. Convert it, and you can see that a single equation x dot is equal to f of xy plus d into y minus x has been created with a numbering of 4a. Now I am just wanting to write another equation, then I have to give the new line comment, that is double backslash, and suppose I am just writing this with dot y is equal to g of xy, and just reverse it dy minus x, this. Now I am writing this. I am just running it, and you can see that two equations, the equal to part has been aligned in a line, and the equation number has been taken as 4a and 4b. In this way, you can write many more equations. Suppose I am just copying these and writing these again to check what happens. You can see that 4 equations has been come, and 4a, 4b, 4c, 4d numbering. Okay, in this way you can use the sub equation environment. Next, we are coming to another subsection that is called equivalent array. So I am creating it here. So another subsection. So this will be 2.2. The heading will be equation array. The equation array contains a number of equations arranged in one place with a numbering 5, 6, etc. Okay. So for this you have to just write begin equnaray equivalent array and n equivalent array and write your equation like you did in the sub equation. But here the alignment begin aligned, end aligned is not given. To align these, we have to use 2 ampersand sign. Whatever you want to align. Suppose I want to align the equal sign in a vertical line. So you have to cover equal signs with 2 ampersand signs. Okay. Now just run it. And you can see the beauty. The equal signs has been aligned vertically. Now you want to check what happens if I don't get the vertical lines here. Suppose I am arranging this equal to this plus, then we have to give the ampersand here. What happened? This equation will be shifted in the left. Check. These equal and plus sign are aligned in a line. So alignment is done is ampersand here. Whenever you provide, it will align those things to a vertical line. Okay. So I am aligning it in the regular way. And running it, then beautiful equation comes. Next, I come to another subsection that is called matrices. Another subsection, it has been taken 2.2, and here I am providing another subsection matrices. If you want to type matrix equation or determinant equation in your LaTeX, then you have to give some comments which I will be showing. Check the matrices, and there are several matrices. There will be plain matrices, matrices with a first bracket, second bracket, third bracket, etc. So in this section I am giving the another command subsection that will be a subsection to this subsection. So subsection is another command here. To create a matrix, we have to write the command begin equation. If you want number, end equation, and inside that you have to give the command begin matrix and end matrix. Begin matrix and suppose end matrix. End matrix. Inside that you have to write it. If you give only matrix, then only plain matrix will be created. Okay. Now I am coming how to enter matrix. You have to give different column in a row. So second column will be given by ampersand. Okay. Ampersand 2, ampersand 3. This is the first row with 3 columns, 1, 2, 3. Give a new line, then 4 ampersand, 5 ampersand, and 6 ampersand, and not giving any new line. Okay. Now run it. you can see that the matrix has been created, but nothing has been created, and the subsection has been created 2.3.1. That means the plane is a subsection of 2.3. Okay, in this way we can include several matrices. Suppose here I am creating the matrix with a subsection, matrices with parenthesis means first bracket. Then we have to use P matrix inside of matrix, parenthesis matrix. Okay, and I am giving a J equal to in front of this. So this is nothing, you can skip it. Just J is equal to some matrix I am wanting to print. Okay, so I am giving 1, 2, 3 and ABC with P matrix. Run it. And you can see that matrices with parentheses J is equal to 1, 2, 3 and ABC, the parenthesis has been included and the equation number has been automatically taken. Okay, now parenthesis with brackets, that is B matrix, that is B matrix. You have to just change it to B matrix, then it will come as bracket matrix. Here you can see that bracket matrix has printed. Okay, next I am coming to insertion of some figures. Okay, I am making this again a section. So section number 3 will be created. Inclusion of figure. Here you, for your readability, how to in LaTeX and give it a percentage command, then color will be changed and it is for your readability. Okay, the section inclusion of figures. To include figure, we have to keep that figure in your working directory. So I am just pasting a figure in the EPS format. Check the figure, this is the figure, suppose this is the figure, and the extension is EPS. We shall use the EPS format throughout this process. If you use PDF LaTeX only, then you can use JPG or JPG formats, etc. But we shall tell you to use the EPS format because the colors or fonts in this format are in the best resolutions. Okay, so to begin figures, we have to provide, to include figures, we require the graphic X package. What happens with given? Just begin figure, end figure, and inside that we have to include graphics. Here option, don't provide first option, and name of the file. What is oak underscore ts, oak underscore ts. Okay, now I am just running it. Just run it. Some warning and error will come. I am anticipating here. Now there you can see that undefined control sequence include graphics. It is not finding include graphics. It don't know what is the include graphics. So before that, we have to use in the preamble use package graphic X. Okay, graphic 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 X, and go to that portion and run it. Okay, some error is coming here. Where is graphic X? Probably I misspelled it here. graph gra. Okay, then it's fine. Okay, it is not coming. Just paste here and include graphics. INCLUDE, include graphics. You have to write the proper pronunciation. Okay. Now I am just converting it. Then check what happened. Inclusion of figure, section number 3, and includes figure, requires graphics package, and the figure is cut somehow. You can see that the figure is cut. So here I am giving the size option of the figure after include graphics. That is width, width is equal to 0.8 text width. That means this is its text width, and I am providing 80% to the width of the figure. So what happens now? Now happens, you can see that the figure has been aligned in the left and 0.8% or 80% of the total. Now, if we want to make it center, then we have to provide backslash centering before that. And here, nothing has been erased, but we, in scientific article, we have to give a caption. So caption, third bracket, and I am giving the caption here. Okay, the caption, enter a caption here. Suppose you can enter anything as caption and label the figure. Suppose I am giving the OAK fig as the label, any keyword. I am giving it OAK fig. Just run it, PS to PDF, and you can see that figure 1, enter caption here. What we have given caption, it has taken, and automatically is that it has taken figure 9. If we just increase it to 95% of the text width, then it will increase the width of the figure. You can see that the width has been increased. Okay, the 0.8% is most favorable. Okay. Next, I am just referencing the figure. So how to reference the figure? From figure ref the label keyword, that is OAK figure, we see that. Then in this portion, figure number will be called, and you can see that here. From figure we see that, just give another enter, then it will be a new para. So from figure, here one thing must be kept in mind, that LaTeX will arrange the figure in the proper place. If you want to place it wherever you want, then you have to use HTPB, here, there, here, top and position and bottom. Okay, these comments, if I give here, then it will come the figure is coming here. So by here comment, you can put the figure wherever you want, but it is easier for LaTeX to provide, to give it independence to arrange the figures whatever it wants. Okay, so we don't give H, otherwise you may give. Okay, now another important part, that is references, is coming, is here, and I am creating another section, that is references. To include references, we shall use the bib bibtech package. Okay, the bibtech package and create a .bib, that is where it is, this. I am just copying it here. You can create some document file, some bib file. What is the bib file? The similar file but with a extension of .bib. The file name may be whatever you want. So here I am giving the bib file like that, @book, and within these brackets, second brackets, I am writing a goal. This is the keyword, and then provide the author equal to, inside the inverted commas give the author name, title inside the inverted comma the title name, publisher inside the inverted comma publisher, and year inside the this. Okay. Next, if you want to cite an article, then we have to provide the @article. This is the keyword, and author, the author names, if there are more than one authors, they must be separated by and. Then title, then journal, then volume, then pages, then year. Okay. In the similar way, second, third, fourth, whatever you want. Now I am just referencing it, how to refer it. So to reference it, suppose I am referencing it. The biorhythmic system is given by, I am just citing those Vishwas 16 and Vishwas 17, two references in a place separated by comma. Okay. So it will call Vishwas 16, that means this reference, and Vishwas 17, that means this reference to 1 and 2. One thing must be kept in mind, the order in the bib file doesn't matter, whichever order there may be, but whatever you cite it here, the reference will come in this order. So first of all reference, my 2016 paper, that is, this will come in the first position, and this in the second position, and another, the goal, the book, in the third position. Okay, so this position doesn't matter, only matter is the site position. So I am just running it. Here is the fourth page and nothing is here. So to run it, you have to run the LaTeX command first one time, then you have to write bibtex space amity.latex, that is file name, LaTeX, then bibtex, and then 2 times LaTeX. Okay, then convert it to PS and convert it to PDF. And you can see that in the pages. Okay, here some error is being provided because in the document I have not included any bib file. We have to give the bib file. Okay, so I am provide the bib files here. For that we have to use these two commands: bibliography \bibliography, the name of the bib file, REFF, and the style of the bibliography. Okay, then bibliography style, that is IEEETR. I am using IEEETR style. So after that, we have to run the LaTeX, twice bibtex, once bibtex, and twice LaTeX. Okay, then I have to convert it. Now check what happens. So references, to include references, So here the references have been taken. You see that 2016 paper, the control of biorhythmicity, control of birhythmicity, that is taken at the first position, then 2017 paper, and then the book. So the order depends on where you draw the citation or the cite command. Okay, in this way we can use several references in your document. Now next, another important thing is the table. So I am coming for the table. Another section is being created, section table. Table is an important part of any document. So the table will be begin as begin table, end table, and make it centering, give it caption. I am giving the caption what has been table of marks, suppose table of marks, table of marks. Then include your table begin tabular and end tabular. Okay, so here you have to specify the columns. If you give C, 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 suppose C, 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 3 columns. Okay, you have to provide. You can provide anything here, and like the matrix environment, you have to use the ampersand to get different columns. Suppose I am giving SL number, name, and comments. So here I am providing first serial number, ampersand. This will create another column, name, ampersand, marks, ampersand, comment, ampersand, and here I am giving new line. Okay, so run it. What happens? Okay, provide it. Begin tabular. Provide it some space. Some error is coming. Extra alignment. Oh, here 3C I have given, but in the body I have given 4. So error is coming. SL number, name, marks, and comments. So I have to give another C. So 4C, 4 columns. And now it is right. PPI, PS to PDF. Okay. Now the table, here the table has been given, but you can see it is not very good because there is no line, no border, etc. So if you want the column lines, then you have to provide this vertical sign here. So I am writing it here and running it again. You can see that vertical lines has been created, and before the serial number, if we want a horizontal line, so we shall give the command H line, and after that a H line. Okay, then it will be created a box. The new line command must be given here. You can see that the box has been created. Okay, now the second row will be same. Suppose serial number 1, ampersand, name is Prakash, and ampersand, then marks is 20, then your comment study more. Okay, then new line, then H line. and run it. You can see that Prakash 20 study more. Okay, in this way you can provide others also. So 2 Animes marks is 50 needs to be more studious, and 3 Kakoli marks is 40 needs to be more studious. Okay, so just run it and convert it to this. So in this way the table may be created. Okay, so this is the way to create tables. Sorry. Now I am coming to another section. Suppose we want some conclusion, then we can make it section conclusion. Conclusions, and here otherwise give the conclusion text here. Now run it. Now run it. So conclusion has been taken. If you want to add some appendix, then you have to give begin appendix and end appendix. Okay, and inside appendix you may give the section etc whatever you want. So I am just copying this portion to my text format, and this one appendix, and just run it. Okay, so after that you can see that A has been created. A means appendix. Biorhythmic energy harvesting model, give it a capital. So with this you can create appendices. Okay, so this is the basic LaTeX uh, document processor for you, the introduction part. There are much more advanced parts. You can see, just I have created some talks here, where it is here. You can create talks or the presentation here. This is the suitable presentation of created by LaTeX. This is the presentation created by LaTeX. You can create this type of presentations also. It's very nice, but a little bit of harder to learn. But once you learn, you can get. This one is created by LaTeX. Okay, so this all for you. If you have any question, then you may ask. So what to you, Sanjay sir?
Yeah, okay, thank you, sir. Uh, any query, dear participants? If you have any query regarding the topic, please put your question in chat box. Hello.
Okay,
Regarding
sir, voice
LaTeX.
pitch is very low. Okay.
Uh, Dear participants, if you have some query, you can discuss with the speaker. Okay.
Sir, can you tell us research topic related to this? Related to what? Related to LaTeX? If there is only LaTeX related, uh, then you have to be developer to make or contribute to LaTeX package. Okay. Otherwise, you can publish your works in LaTeX. LaTeX is a platform. You can write your documents, prepare your documents or books or anything here.
So Dr. Biswas sir has explained everything that is need to writing the articles, yeah, books, that is references, tables, equations, figures, how to add in the latex. Latex is a platform where you can write your documents like research papers, letters, whatever business letters and so on. He has started the latex installation, the latex to article writing, yeah, setting the figures, how to erase, how to rectify the errors in latex writing. So latex is demand of times. One who want to write your articles, particularly publish your articles in science, engineering journals. So most of journals wants their source file in a latex typing, and most recruit journals, their demand is that if you write your source file in latex, that is they think that you are more expert in your research papers, in research writings. So we hope participants will utilize these sessions with his curriculums. And my we add to something. Uh, you put latex in practice, then you will within 1.5 hours you will learn all these things. If you have any problem, you write only write the latex code of these equations, whatever you want. All command will come. You put and say put and run this your latex for one. There are two text and we need it. Yeah, your purchase source the purchase your file and so on. So I once again I would like to thank you from depth of my hearts for accepting my invitations. So thank you. Looking forward to seeing sir. Thank you, Vishwas sir.
Thank you very much.
Over.
Okay, Debrata,
Yes,
I
yes,
have a question.
yes.
Uh, how this Kyle latex is different from normal Kyle platform?
Uh, Actually, latex has many platforms. There is several products has been created in latex. So this is the requirement based formats. If you want the Kyle latex or anything else, you have to just check. I don't know actually what is Kyle latex. Okay,
Achha.
so
Okay, actually that we use normally in Linux
okay,
and
okay,
latex we can use in Windows also.
okay, obviously.
Thank you, Dr. Devrita, for
Okay,
a
thank you,
nice talk. Thank you very much.
thank you.
Okay, dear participants, we will start our next session at 11:45. Okay, till then we will take short break. See you at 11:45. We have Professor Narsingh Jha, who is working as an assistant professor in the Department of Applied Mechanics, IIT Delhi. Professor Narsingh has completed his doctoral from Indian Institute of Science, Bangalore, and worked on the two-phase flow and microfluids. After completing his PhD, he went to UK and worked in the University of Cambridge as a postdoctoral researcher. After UK, he joined Weizmann Institute of Science in the Department of Physics of Complex Systems, and there he was a PVC VAT postdoctoral fellow. He has published several SCI indexed publication, and after Israel he went to IIT Delhi and joined as an assistant professor. So, Narsingh sir,
Yeah.
please, now audience is yours, and Please start.
Thank you, Vishal. Thanks for the introduction. And thank you for the invitation. And it's a pleasure to
You're
talk to.
welcome.
It's a pleasure to talk to young mind of this country. And there are two motives with which I come here. One motive, obviously, to tell about my work, to tell about what I'm doing. But then there is a bigger motive to some of these things is that when I talk to at least the current faculty of this country, I also want to motivate them that there are big opportunities lying ahead, and we need to put in our efforts so that we train our students as well as we also find out hidden physics. Okay. So with those motivations in mind, so that from today is this, you learn both aspects of this. There are something which you can teach to your students, but there are way more opportunities lying in front of you because there is a lot of unsolved problem in this area which is going to affect humanity a lot. Okay, so the specific topic which I'm going to talk about is the role of large data in studying turbulence. So first I'll tell you what is turbulence. Then I'll tell you why large data is needed for studying turbulence. And with that, I'll tell you various examples on which I personally have been working on, and will tell you that what are the different challenges which I'm trying to address and how you have an opportunity to start working in some areas. Okay. So, yeah. And obviously, we'll also talk about, I'm an experimental fluid dynamicist, okay? And that basically means I mostly focus on experiments, but if you see my background, you will see that I did my postdoc in maths and physics department, and I come from my PhD in mechanical engineering. So technically what I broadly do is I take an engineering problem, try to look for an engineering solution with the help of experiments, maths, and physics, okay? So few examples which motivate turbulence or studying turbulence, obviously is building flows around you where you are sitting right now. The flow around you is going to decide your comfort zone and what are the optimal comfort zone. Obviously, most of us have faced air pollution in some or the other form in this country. So that's another problem where turbulence is going to affect the transfer of fluid parcel. And cloud, rain, ocean, environmental flows, blood flow, everything, all of these flows are turbulent in nature. And I can tell you most of the flow, either it be river, most of the flow, what you see around you, most of them are turbulent. There are around 99.9% chances that the flow, what you see in real life are going to be turbulent. Okay. So, and then thus we need to understand it better for better utilization of it and better engineering. Okay. So first, let's see that when I talk about fluid or when I talk about turbulence, what is the governing equation of that? Okay. So you can relate some of these. So this is a standard Navier-Stokes equation. It was first given by Navier and Stokes. That's why it's called Navier-Stokes. Basically, it's momentum conservation equation. And basically, one can expect from momentum conservation equation that you have first unsteady terms, okay. Then you have convective acceleration term, which is because of the convection of fluid particle and gradient of velocity in the fluid particle. So this two is the acceleration term, and combination of these two gives you total acceleration of fluid particle. And obviously there is acceleration means there has to be some force acting on it. So the first is this pressure gradient force. Okay, this is gradient of pressure, and this is your viscous stress. Okay, which comes out from the molecular level. That viscosity arises from this, random fluctuation of random vibration of these molecules, and which helps in exchange of momentum because of this, and because of which you have this viscous force. Okay, and but you will see the biggest demand in all this, or at least what I feel is the biggest demand in this, is this non-linear term. Okay, and this nonlinear term comes in convective acceleration, and this brings in lot of instability. So your flow is first laminar. That means flow is smoothly going from say point A to point B. Then some of these non-linearity brings in the chaotic motion of this fluid particle or instability of flow, which brings in brings in the transition from laminar to turbulent flows. Okay, and the moment it becomes it transitions to turbulent flow, the mixing increases, the total resistance by the flow increases. Total resistance by the flow increases means to flow these fluids, you need to put in lot more energy as compared to laminar. And if that's so, the first question what one would ask that what is the basic thing by which the amount of energy which one has to feed in to drive a turbulent flow is much higher compared to laminar flows. Where are those energy going? Okay, and then we'll see as we move forward, a lot of those energies are going into eddies or vortex. So the big aspect of all these things, what we are going to discuss today, that basically we are going to talk about turbulence, and the biggest demon of turbulence is this nonlinear term. In mathematical form, in physics form, or in real space form, it's the eddy. Okay, so we are going to focus a lot on eddy, and the thing is, how can we control eddy? How can we understand eddy better? Okay, so now you see that once you have a velocity field, okay, and obviously now we are going to assume that the velocity is turbulent. That basically means that you have a mean based on which, and on top of that, you have some added fluctuations. That basically means that, can you see my cursor? Vishal, can you respond that you can see my cursor?
Yes, 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 yes.
Okay, fine, perfect. So that means that there is this dotted red line, that is your mean flow, and on top of that you have these fluctuations, velocity fluctuations. And the smart mind of Reynolds came in. Reynolds was a scientist who worked a lot on fluid mechanics. And most of you must have heard about Reynolds number, that comes from the same scientist. And what he came up with the idea of that this velocity as a function of time can be split in two parts. First part is the mean, that dotted red line, and based on top of that, you have this black line, that is the fluctuating part. So the instantaneous velocity at one point now can be split in two. One is mean part, another is fluctuating part. Okay. So now let's look at the governing equation for this as we looked in the beginning, where I only talked about that. If you remember, there were unsteady terms, there were convective term, you had pressure gradient, and you had viscous term. All that was in instantaneous sense. Okay. Now what I bring in, I try to bring in the mean flow and fluctuating flow. Okay. But the moment you want to bring, so what you have to do is you need to feed this ui into the previous equation what we had. And what you get is you now get the mean term, you also get some fluctuating term. Okay. And you split it in and write it in tensorial form. So apart from this mean equation, which you already had from here to here, you remember it's almost the same. But apart from that, now you have one extra term, that is ui prime uj prime. Okay, that's called the Reynolds stress. Okay, and this Reynolds stress brings the biggest trouble over here. And the source of this Reynolds stress, as you will see here, is this convective term what you had, u dot grad of u. Okay, that non-linear convective term is now bringing one extra term, which now brings the closure problem of turbulence. Okay, and what is that closure problem? The closure problem of that is, once now if you write down the equation of ui, you had three equations. Now you have six unknown. So you have unknown of u, v, and w. Apart from that, you have now u prime square, ui uj bar, that will give you u prime square, v prime square, w prime square, u prime v prime bar, u prime w prime bar, v prime w prime bar. Now we have six extra unknown. Now what one would certainly do is, let's write down the equation for that. The moment you write down the equation for your ui prime uj prime, that Reynolds stress, and then now you have six equations for this because you have six variables there. But then you have now extra, rather than now double correlation, now you have triple correlation. Okay, so your number of unknowns are always increasing the number of it. And then one can go on. Now you try to write down the equation for triple correlation. Then again you have more unknown because now you have fourth correlation. Okay, and that's the closure problem, that your number of unknown is always more than number of equations. That basically means that you cannot solve it analytically. That's the reason that we call it the millennium problem, And there is a very nice anecdote that, one of the big scientists, when he said that once he meets God, he will say that He's going to ask God that what is quantum and what is turbulence. And he envisioned that God may have answer for quantum, but I don't think God will have answer for turbulence. And the reason for that is we are here. Okay. So can we do something for it? What can we do for it? Because this is related to our real life. Okay. And the biggest problem over here is this closure problem, that your number of unknown is always more than number. That means that you cannot solve it mathematically. That means that for understanding a lot of these things, you cannot purely rely on applied mathematicians, okay, or pure mathematicians. You need to go beyond mathematics to understand some of these. Okay. So then how do you handle these kind of equations? So one is obviously a statistical approach. You take the average and you write the Reynolds average equation. And what you saw that you had non-closure problem. But then you might say that why would I split it? Because I split it and then I have more problem, because you only told me that you break in terms of u bar and u prime, and you broke it in terms of u bar and u prime. Now you are saying u prime is causing problem. Okay, I would not do that. I can just write the equation for, I can just write down the equation for instantaneous velocity. And if you do that, then there is inherent chaos in u, because you have this random fluctuations which you saw. Okay, and then inherent chaos becomes brings in other kind of problem. Okay, then as I told you that you cannot completely rely on applied mathematicians, and if that's true, then what do you do? Okay, so if you cannot rely on maths, then what you are certainly do experiments. And what do? You do a lot of numerical simulation. But then how do you do numerical simulation when you have a closure problem? Okay, because you can solve the equation numerically if it's closed. Okay, if it's not closed, then how you solve numerical equations? That I'll come in slightly later. Okay, and then you will see that once we talk about numerical scheme, we'll talk about Reynolds average equation, large area simulation, direct numerical simulation, and we will see that in all these cases that closure problem needs to be handled separately. That we'll talk. Okay, but my friend, it's fine. Maths has a problem. Numerical studies has a problem. Experiments has no problem. Law of universe is very fixed. Okay, so if experiment does not have any problem, that basically means that what it's going to govern. If what if I measure those things and try to insert a lot of physical insight of, okay, because you have closure problem, but your governing equation is there. Okay, just that you cannot solve those equations. Okay, but what if I measure all the variables, and even if I can't solve it, why do I need to solve it? I measure all the variables, I put in over there, I know my governing equation, I get physical insights from governing equation, and do lots of experiments to understand that. Okay. And the experimental tool, what typically people started using in these kind of things, the first one is hot wire, that came the first. Okay. And that was the first time, because now, as I was telling you, that these velocity is a function of time. That basically means that you need a measurement tool which has a very nice temporal resolution and which has nice resolution on velocity scale. So and hot wire suffices both. It has very good resolution in measuring velocity, and it has very good resolution in time, such that all the scale of turbulence can be made. So the time response of hot wire is much smaller than the smallest time scale what you have in the flow. Okay, that's first. Second, but then this hot wire is a point measurement. But many times once you do point measurement, the first question to ask would be what happens in field. Then came the next advancement in is in fluid measurement, that is the PIV, particle image velocity, that came in early 90s. Okay, and that matured around till 2000. It's still maturing, but now it's at a stage where we can reliably use it for a lot of purposes. There are obviously multiple varieties to kind of PIV what you have. You have 2-dimensional, 3-dimensional, 4-dimensional, you have volumetric and time. Okay, and then you have time resolved, multiple time responses, you have multiple spatial resolutions, so you have wide variety of PIV, and you have multiple supply market which supplies these kind of things. But many times for your need, you might have to develop some things because it's still not in the stage where it can be customized. There are a lot of on-the-shelf solutions, but you still might have to modify based on the kind of problem what you are. Okay, I'm sorry. So once particle image velocimetry, after that is the stratigraphy, because stratigraphy helps you in. So now, as it's fluid, you might have different density. Okay, that might come in where you are sitting. The temperature close to your body is relatively higher to the outside if your AC is running in your room. If AC is not running, that means as it's hot weather in India, probably your temperature beside you is different compared to your body. In that case, you have a temperature gradient set up over here. And because of that, you will have a density field. So density field might let you know a lot of things about the field mixing of fluid. First, second, density field will also help you because your governing equation has acceleration. And that acceleration depends on what is the density of your fluid, which in turn is mass if you multiply the velocity. So density helps you and density field helps you in putting into the analytical equation to get more insight about the momentum exchange. Okay, so now I take you the one of the thing which I told you that experiments give you a lot of advantage. So this is the experiment which was done around 90s, 1991 to be probably precise, 91 or 92 something. Okay. But it was published in 94 because they took some time to publish this work. Okay. So this is done by Sadogi and Professor Vidavali. And this is done in world's biggest wind tunnel. Okay. That wind tunnel is in NASA. It's run by NASA Ames Research Center. Its test section is 80 feet by 20 feet. Sorry, 80 feet by 120 feet. Okay. And that basically means, say, typically if we are 6 feet, so 20 of human, that tall is the height, and then you have width. Okay. That big is the wind tunnel. Okay. And the velocity what one can achieve is much higher over here. And that gives you Reynolds number beyond. This was the largest Reynolds number which one could measure. And why that was measured? Because Kolmogorov in 1940s gave a theory based on a statistical tool, what I was explaining earlier. And using the scaling argument, he gave some of the length scale in turbulent flows. Okay. And to prove those statistical and dimensional argument theorem, they did these large experiments that once the turbulence is fully developed, can some of these things be checked. So this was the first experimental proof of Kolmogorov theory at full scale, which was given in 1940. So it took 50 years to get the experimental proof of some of this. Okay. So, and the thing which help you over here is second order velocity structure function. And that basically is your ux prime fluctuating velocity. That x is your vector, position vector, x plus rex. R is what you march in ex cap direction, minus u prime x square, and then you average it over multiple samples. Okay. And this gives you energy, how much energy is there. So second order structure function does scale with 4/3 of energy in the eddies of size r, because this is the r which you have. So this second order structure function is the velocity of r, which is the separation between two, which you use for correlation. And the 3/4 of this gives you energy in the eddies, which is at the scale r or a smaller. Okay. And this also helps you in finding some of the Kolmogorov length. Okay. And let's see that where we are compared, these experiments compared to why this experiment was needed. And with today's computational capability, can we reach something close to it? Okay. So if you look at these slides, so the R lambda over here was 1450. Okay. Reynolds number based on Taylor microscale. And if you have similar R lambda, so see, if I could do numerical simulation with current state of the art, say 2000, what it was there in 2000. Based on that, to model R lambda of 800, it would take 5,000 years. Okay. I repeat, to model R lambda of 800, it would take 5,000 years of CPU hours. Okay. So means, and the one which we have to do is 1450. Okay. So you can realize the kind of time what would be needed to model some of these kind of. And then with that, you appreciate the kind of experiments what has been done and the value of the experiment. Okay. So now let's try to understand some of the spectrum and its wave number spectrum. Okay. And in the wave number spectrum, at the largest length scale, you have highest energy. And as you move towards the smallest scale, that's Kolmogorov, where viscous dissipation starts playing a big role. And that's where you have little energy and it's being dissipated. And the genius argument of Kolmogorov using dimensional theory gave that in this region, your spectrum should go as -5, right? Okay, spectrum should go as k raised to -5, right? Which now is well verified experimentally that yeah, that's true, and then we get okay. And basically what you have a length scale, which is energy containing length scale, which you saw over here, this largest length scale, where the energy is proportional to this length scale. Over here, it depends on the smallest scale, but in between you have very nice scaling, that's -5. And now I was telling you, so all that now was experiments and where is numerical simulation compared to experiments and what's the usage or advantage of and what's the need of doing experiments. Okay. But now let's understand, because I told you that this governing equation for this has a closure problem. But then I also showed you result from numerical thing, and I showed you that the kind of experiments what have been done, the typical time even for R lambda of 800 would be CPU. For 5,000 CPU, it will take 80 years, something like that. Okay. So now you have this term, right? Ui prime uj prime, okay, or vi prime vj prime, okay, and you want to model this term, okay, because this is bringing in the closure thing, and you have to model this fluctuating quantity in terms of mean quantity, because what you have information of is all about mean. If you just remove these fluctuations from this, I would just like to remind you, okay, that if I just model all these fluctuating terms, ui prime, uj prime, if I model this in terms of mean, then my number of equations will be 3, my number of unknowns will be 3, so I should be able to solve it. Okay. So that basically means that you need to model it in terms of mean gradient, and then brings in the turbulent viscosity, because this term is coming up because of difference. You say that ui prime, uj prime, that Reynolds stress is proportional to mean gradient, and the proportionality constant is turbulent viscosity. Okay, but mathematically you understand why one would do it, because there is a need to do it, because otherwise you have a closure problem. But you cannot certainly do something because of mathematical argument. You need to back it by physics. Okay, so the first physical question to ask would be why Reynolds stress should be proportional to your mean velocity grade. That's first question which I asked to myself when I looked at some of these things. Okay, so there is no physical basis. It's just that you have that available over there, and you have a fitting parameter over here. Okay, so fine, fitting parameter can keep changing so that you match this, but that still does not tell you that why Reynolds stress should be linearly proportional for us. So then there are other model, nonlinear eddy viscosity, where you say that okay, it's not only linearly, it's non-linearly proportional, but it has been shown once they do numerical simulation that for a lot of cases even this linear model does work. Okay, so it's rather than having physical argument, you put it in and you see that yeah, non-linear eddy viscosity model, yeah, it performs better, but for most of the cases that within reasonable accuracy, even linear model does a good job. Okay, and how do you do that? So now your eddy viscosity that goes as rho L squared dou bar by rho y, where L is your mixing length. Again, mixing length is a new term. Okay? So, and then in the beginning, again, they used to fit various mixing length when this is satisfied. But again, there was one extra variable. So slowly they went into higher order models where they improved more. Okay, and then the generalized CFD equation, as you remember from there, is you have unsteady term, you have nonlinear term, you have some diffusion term, and so on. Okay. So there are various ways, you can use it for mass, all three momentum continuity species. So a general equation has been developed for CFP. Okay. So that was again bit of numerical aspect. Now we are building on the schemes, what all the scheme can be. First, I explained you why turbulence has a complication. Then I showed you that what are the two largest scale thing. Yeah, I forgot to tell you one thing. The wind tunnel which I showed you, NASA wind tunnel, where they did lot of experiments. The power requirement for that wind tunnel to run is 60 megawatt. You have to realize that with 60 megawatt you can run, you can power a city in a small. We can power a small city. Okay, so that was the power requirement to measure some of these things, which validated for the first time the Kolmogorov theory at sufficiently high. Okay, so now you have, so that was after that I talked about the numerical methods, where are they? And after that, I talked a bit about numerical schemes and how do they handle some of the closure problem. Now I'm going to tell you about experimental methods. Experimentally, how do we do? In the beginning, I explained you that we typically use hot wire, PIV, and stereography. Now I'm going to explain you PIV in detail. What is PIV? So what typically you do is you add in a lot of particles. Okay. And once you add these particles and you assume that these particles are going to follow the fluid faithfully, these particles then technically is a marker for fluid because they faithfully follow the fluid path. Okay, so they are the faithful tracer. Okay, so that velocity of fluid at any point is equal to velocity of tracer. So once you choose tracer, there are ways to choose that. There are non-dimensional numbers in which you have to match to choose. And once you have chosen it, you can assume that they are going to faithfully follow. So now to get the velocity of these particles, typically these particles are of the order of 2 micron, 3 micron, 10 micron. So now if you get the velocity of this 2 micron, 3 micron particle, and then you assume that, not you assume, based on your arguments, you say that these particles velocity is same as fluid velocity. So what you measure is fluid velocity. Okay. So now what you do, you take the particle image at time t1, and then you take this image again at t plus delta t, and you see that from t to t plus delta t, how much this particle has moved. Okay. Now, as you can imagine, if you just track each individual particle, there is probability that if this is two-dimensional and your flow is say has bit of three dimensions, some particle will go in, some particle will come out. So in that case, what rather than tracking each individual particle, you track a box particle. That gives you much better correlation, because now if you have multiple particles, then the distribution, the pattern of the distribution of particle is going to give you the better accuracy in the correlation. Better accuracy in the correlation, right? And then you do a lot of peak search algorithm to find out where the correlation. You might have multiple peaks, and you need to optimally choose that which is the physical peak over there. Okay, but once you find out this delta t, once you find out how much this particle has moved, okay, that means we will know delta x and delta y. It's two, and once you know delta x and delta y, you know what is the delta t over there. And once you know delta t, delta x, and delta y, what you get? You get the velocity. U is basically your delta x by delta t. V is your basically delta y by delta t. Then you get the velocity. That's what I was telling you. Once you do experiments, then the closure problem what you have. Now you have instantaneous velocity. So if you have a good, nice spatial and temporal resolution, you just get these, put into your equation, and you have all the physical argument. And that's where I am placed. I basically do this. The tool which I used mostly is PIV. Obviously, I do other kind of tools. I measure pressure, velocity, temperature, density. But the most optimal, most frequent tool which I use is PIV. Because there are other tools which are typically used, that is hot wire and then laser Doppler velocity. Okay. So then how do you do that? That's the thing, how you get the image. But typically, how do you get these kind of images in an experiment? So you have a laser, you expand this laser into a sheet, you shine your fluid, which is added with particle in the sheet. Okay. And then you put your camera here and put your camera here and get the image of particle. Okay, and obviously you need to certainly generate a flow to do this. So you have a valve, you have a flow meter, you have, and then if it's gravity driven, this is gravity tap. Okay, and then you see your particle with holographic sphere. It's typically in this case for this particular kind of the kind of particle what we use is roughly of order of 10 micron. Okay, so that's fine now. Yeah, so you the kind of camera what typically we use is you need to have good spatial and temporal resolution. So camera what we have is typically having high frame rate and high frame. Okay, yeah. So with this, you see this. This is from our experiment in the lab. You see these particles which are moving in time, and then you first track these particles how they are moving. From this, you get the instantaneous velocity, and you split it in terms of mean and fluctuation, and then you already have the orientation. You try to get the inside physics of it. And I told you in the beginning, you remember, and when I was doing even this velocity structure function, I told you that a lot of the big demon of turbulence come from the physical insight is the eddy presenter. You must have seen a lot of rotating fluid wherever you when you see some flows, either you see a rain and flow, you might have rotate. If you are sitting beside a river, you might have seen this rotating vortex near the edge of the river. Okay, so those are the vortex which are the main domain of creating turbulence. So we broadly look into that, and obviously we look into all the energy containing fluid. Okay, that is one aspect of it when there was single phase, but many times your fluid is not in single phase. Okay, you have say two phases, you have water and you have air, both. Okay, and the one nice example of that is a ship wave. Okay, so if you see behind the propeller of ship, it's mixed with both vapor, water, or air water. Vapor basically sometimes you have cavitation behind the propeller. So you have multi-phase problem there. And that, if you look from the naval aspect, that wave is used to detect the ship or submarine. And that torpedo uses to kill the propeller. And propeller is the driver of the ship. If somebody kills a propeller, basically your ship or submarine is taken. Okay. So we study multi-phase flow, and obviously it's used in mixing and industrial flows. There are multiple applications. This one, multi-phase flows. Okay, oil emulsion. Okay. So in case of multi-phase flow, what typically we are interested in is what is the dynamics air. So what you see over here, these are air bubbles, okay, in water. So what we do is we take the capture of this multi-phase flow image. So we take the image of these bubbles, and I want to understand the dynamics of these bubbles so that I can understand what is the source of acoustics, what is the mixing characteristics, what is the multi-phase component, and obviously there is fundamental aspect to it, how does it affect mixing, how does it affect the films, and there is practical aspect of it, that how does it, what kind of acoustics does it create for multiple. Now, once we now want to characterize this, what we do, we capture this image, then, and obviously this talk, we are going to talk about data, and we are talking about large data, okay? How we acquire large data, and I showed you what's the usage of large data. I showed you, how large data is generated in experiments, large-scale experiments, because you need both spatial and temporal resolution. And in numerical simulation, again, we have volumetric spatio-temporal information. And some of the measurement as turbulence, you need to generate large data. So there is a big area over here that people generate large data. They have to organize large data to understand turbulence. Okay, just to give you an example, typically I take 30 lakh, 40 lakh image for one variable of experiments. Okay, and then I take 40 lakh image, then process it on high performance computing, on high performance computers to get the velocity information what I showed you about. So to get velocity out of it, when I have 20 lakh, 30 lakh images, to get the full spatio-temporal information, I think need to handle very large. That's for one variable. Okay, and as your governing equation is not right, you need to do it for multiple parameters or control parameters that you use in physics to understand the physics of it. So you can imagine the kind of data which is for for one experiment, I typically generate a terabyte of data, and let's say how to do 10 to 20 experiments, like hundreds of terabytes of data is a typical thing in my lab. So typically, that's the one reason I wanted to tell you that to understand problem from large data. And then what you do with large data to identify the pattern, to identify the hidden figures is the one which we are discussing. Okay, yeah, I was here. Then you improve these images. You might have seen some improvement here. Then some of these some of these are blurred, so you need to remove some blur. Okay, and then after that you detect the edge through Canny algorithm. Okay, and then through Hopf transform you try to find out the pattern in this, and then from there you detect the circle and radius and location, so that you get the location of each bubble, radius of each bubble, and then once you track it in time, you get the information of how the diameter is evolving, how the location of bubble is evolving. Okay. We also use stratigraphy. First, I did to get the density contrast. So if we have mixing of two plates, then we do stratigraphy to get the density in two fluorescent time. Okay. And once you got this say bubble diameter, now you need to look at multiple such images to see the your bubble size distribution. What is a typical bubble size? Then you have to match it with practical application. So say we are modeling shift weight. So you know the bubble size distribution shift weight, you do these things to see that, is how close is your bubble size is. Then we look at acoustic characteristics in the laboratory and match it. So in all these things, I did not tell you in the beginning that how your stress, when I was writing my quiz, that how your stress is related to shear stress, typically is related to shear strain rate. You might have studied in your bachelor's day that if the shear stress is proportional to shear strain rate, and then we call it Newtonian fluid, and the constant of proportionality is called viscosity. Okay, that earlier example, all the examples I took was fluid. Then one obvious question would be to ask is, what if that relation is not linear? What if shear stress is not proportional to shear strain? And that means your proportionality constant is not viscosity. That means your flow is not Newtonian. So this particular piece of work which I'm going to talk now is for non-Newtonian fluid, where viscosity is not constant. In that case, we want to look at instability and turbulence. And this work we did when I was postdoctoral at Weizmann and Rizal. And what we looked at, that we found out a lot of very interesting feature over there. We found out there is new kind of wave once the flow is non-Newtonian. Those waves are called elastic. We named them elastic waves. We looked at new kind of instability, non-Newtonian instability. We looked at these wave patterns over there. We looked at algebraic decay. I was telling you when I was talking about the spectrum that typically turbulence is -5. We realized it's elastic pattern. Then the spectrum is not -5, it's typically -3. So all those was a thing which, and obviously the data which was generated over here again, a couple of terabytes. Look at the space here. And with those large data, for the first time, we were able to look at non-model instability and some of the couple of other publications in these lines are lines of somehow. Okay. So that was related to non-Newtonian flows. Just give me a minute. We also use it to understand the building flow. Okay? So say this is the classroom where we want to understand how the flow over there. And during the COVID, the one big question was to ask is, if the human people are sitting over there, and if there is a COVID patient, what is the probability that some of the patients will have COVID? Okay, that's first question to ask, which all of you can relate to. And the other question to ask is, what is the minimum energy required to air condition this room, all of these rooms? or air conditioning, central air conditioning. How can we optimize the energy requirements? Basically, it was looked from two perspectives, energy and transmission. And this is submitted in Nature Communication. Okay, so this is a classroom which was 150 seater classroom. Okay, and what we did is we measured CO2 in the field. Okay, so these black symbols are the place where we put a lot of CO2. Okay, and what we are trying to do again, you have to relate. Okay, these CO2 sensors have very good temporal resolution. We put at multiple space. So it has temporal resolution and we have put at multiple spatial distribution. That means we are going to get the spatio-temporal distribution of CO2 in a classroom. And okay. The moment it is occupied, you need a camera to see that कितने लोग बैठे हैं इस classroom में, what is the occupancy in this classroom, and obviously you have air condition over here. You want to see that how much fluid is coming through air condition. Okay, and obviously the more there is supply, there has to be return. You want to measure what is the return this. Okay, and what you have to measure also is the ventilation. It's ventilation to that. Okay, so and first let's look at the CO2 distribution in class. This is the exam which is being conducted in the classroom. So this is occupancy as its exam means students are well behaved and well distributed. Okay, and so okay, it's joke only for faculties. You can't crack these kind of jokes with students. Okay, so yeah, they are uniformly distributed in the classroom. We have some regulator there, and we measured the CO2, and you see the CO2 over here is around 1600, 1700. And as per the guidelines, the CO2 distribution in the working place should not go beyond 1000. Okay, one can imagine if CO2 which you are breathing has lot of CO2, that means what? You will go oxygen deficit. And what happens once human goes oxygen deficit? The first thing, if you are staying in a oxygen deficit environment, it's going to affect your brain stability, because the quality of blood, what should reach to brain is not good. Okay, obviously today I'm not talking about that aspect of it, but I certainly work a lot again on data and cancer victims, where I look at blood and turbulence in blood, which I'm not going to talk today, but another aspect of looking at the role of turbulence in human vascular system. And for this particular case, if your quality of blood, which is not going to reach your brain, means your brain is slow. That means that, if the CO2 is much higher than the prescribed limit, means people are going to behave slowly, means their response time is going to be down. And obviously, if they're sitting in an exam, the worst thing what you would like to have is your low response. Okay, and how does this evolve? So you see that when exam started at 3, and the CO2 was very small, 600, and then at 315 it was around 700-800, and 330 it was 900. This is at 345, it was 1500, and towards the end of the class it was 2000, 2 times the prescribed limit. Okay, so we look at this aspect that what is the optimal distribution, what one should have in a class, and later obviously we'll relate it to COVID transmission, because CO2 is a proxy for viral transmission. Because CO2, because virus, if somebody is infected, he or she is going to transmit virus, but parallelly same person is also going to transmit CO2. If I measure CO2, that will be a marker for viral transmission also, because both is being transmitted by the same person, right? Okay, then we looked at, that was one case where occupancy was fixed. Then we varied the occupancy. Okay, in last slide I showed you a spatio-temporal distribution, because you look in space, you look in time for one occupancy. Now, what if number of occupancy in the classroom is different? Again, you have large set of data, because we look at a lot of these evaluation over time. What I'm showing you is only 4%. Soon you will see the very large. Okay, so now as occupancy increases, you see what happens when occupancy is 20, the class is say CO2 ppm of 600. If 57, then it's around 900. Occupancy is 100, then it's 1500. And if occupancy is 150, the CO2 goes to 4000, 4 times the prescribed CO2. That means your response time is there. Okay. And now what I was telling you about large data, again, come back to large data. What happens to all this evolution? Because when I showed you screenshot, I only showed you at few times, but we have data at very large time. So we have large set of data for multiple, and we have multiple sensors for data out of it. And what certainly you can see, there are very different kind of evaluation for different kind of occupancy. So the one, this is with list occupancy 20, then this is 57, this is 100. Okay. So now let's look at one particular occupancy. As I was telling you that, once you measure, you have experiments, then you can use your governing equation to find out a lot of identities. Okay. So what we do, we now develop first we look at this, what happens to CO2. Okay, there is no occupancy, there is no, classroom is empty, CO2 is constant and at very low value. As people start getting in, your CO2 starts increasing exponentially. And at this point, all the students has reached in the classroom at 70 minutes. And after that, exam starts. At this point, exam starts. And then you see the pattern, growth rate is very different. And at this point, exam stops and all the student leaves and you have exponential. Okay. So this is the measurement what we have. Okay. Now what can we do? Certainly try to develop a mathematical model for this. Obviously, it will be a reduced order model because we are going to simplify your assumptions. We are going to simplify the physics, and with those simplifications, we are going to look at what can. Okay. So what we assume, as you saw, there is a field, a spatio-temporal spatial distribution. What we are assuming that for now, say spatial distribution is one, or the gradient is relatively small, the role of gradient is not much. Then if the concentration is constant in the classroom, but it's a function of time, because you can see there's a strong function of time. If it's a function of time, can we model it? Okay. Now you can see this is a basic mass conservation equation. Okay, people are exhaling something. To this, you are going to add some air to it, and you are taking out some air, and there is some leakage. Okay. So the first thing is to find leakage. So you find leakage from here, because at this point, all other parameters are okay. जितना हवा आ रहा है उतना ही जा रहा है, कोई ऑक्यूपेंट नहीं है, तो वो कुछ ऐड नहीं कर रहा है, जो भी है बाहर जा रहा है, बस वो लीकेज की वजह से बाहर. So what we do is we use this to find out leakage, and once we know leakage is a geometrical parameter. It's independent of number of occupants. Obviously, there is assumption here that density is constant. With those assumptions, we try to model this. That can we model the growth? Okay. So obviously, these are the equations which I told you in simplified manner, which is developed by us for multiple cases, which I won't get into details because I'm running out of time also. Vishal, please let me know once I have 15 minutes so that I'll rush and stop at that. Okay. So now we develop the mathematical model once the occupant is changing, because we have image, so we know number of occupants. We know the rate of change of occupant. For that case, we model. So this blue line is the model. This symbol is your experimental data, and this light blue shaded area is the error bar that we have for these kind of. Okay, and this is once they are, number of occupants is constant. Everybody is sitting in the classroom and exam starts. See how well we have been able to model this. Okay. And once you know the ventilation rate, we know the number of occupants, and if you change the number of occupants, you see what is the probability of others being infected if there is one or two infectors. Okay. So these three different symbols are: if number of infector is 1, what is the probability? If number of infector is 5% of total population, what is the probability? If number of infector is 10% of total population. Okay, and obviously there, you see there are, you might have, once COVID was on, you might have realized there are different kind of emitter what we can talk about. Okay, that's the viral load what one is going to put in there. The low emitter, medium emitter, high emitter, super emitter, all these different things actually has been used during the COVID time by the viral load. Okay, that was from the viral thing. Again, now from CO2 thing. Now I showed you in the classroom, the class was not safe to sit in the classroom because the number of occupants was more. But now as we have developed the model and we have tested our model and experiments, now we are going to use this model to develop a guideline for designer. अगर occupant say 30 है, occupant 50 है, occupant 75 है, by varying the occupant, okay, uh, कितना time रहेगा, and obviously volume is also fixed, constant volume and constant this one. What is the time for which class is safe? Okay. Now you see, as you increase the occupancy, we have put the safety limit at 800. As you increase the occupancy, your safety time, the time by which, the time till which your class is safe reduced. Okay. So for different ventilation rate, your safety increases, and you see that as you increase the occupancy, or this regime falls down. Okay. So the same class is safer for lesser time if the number of occupants is more. Okay. So all that now you can find out for how much time it is safe. That means if all of you are safe, rather than having an online session, if you would have this in a seminar hall, by knowing the number of occupants and the volume of seminar, we know that by this time seminar room is safe. We also sit. After that, this seminar room is not safe because CO2 is way more than the prescribed limit. And the typical say for 100, for typical seminar room for 100 sitting occupancy, it's safe for 1.5 to 2 hours. That's the reason that tea break is not only designed to have a break for this, it's also a break because the classroom is no more safe. Okay. Now, obviously, I do some numerical simulation also with some of my students, and this is my first PhD student who started work. And he was the first student, my first PhD student. I start catching up on numerical simulations. Now I'm going to show you some results on numerical simulation. Obviously, I'm going to use those models, whatever I told you, the viscosity model and those to fill the closure problem. With that, let's look into what happens. Okay, so first let's look at the example. Okay, so the example is, say I'm sitting in an air-conditioned room and outside is hot. That basically means there is a density gradient. That basically means that if I door खोलता हूँ तो मेरा ठंडा हवा बाहर. You must have faced it in a mall or waiting somebody else outside somebody else's office. If AC is running, the moment you open, outside itself you feel the cold air because the cold air started coming out and hot air started going in. That cold air that you feel, and you will typically realize that cold air you don't feel at the face. Cold air comes from the bottom because it's heavy. Light, hot air which is light goes from the top. Typically, you might have seen that. Typically, you feel colder near your leg because cold air typically comes through the bottom because that's heavy. Okay. Now, the thing is, obviously, that cold air you are putting some energy to make it cool. You would not like to lose it. One way. Other way is that as cold air went out, because of continuity, hot air will come in, and certainly you don't want hot air in your room because you have no cool. Okay. For a typical thing for a one-man office, it might not be important. But say if it's an office environment where people keep continuously coming in and going out, then this becomes a big challenge. And this is the work which I started in Cambridge when I was there, and then I continued. But what I did in Cambridge was experiments that I'm doing over here. Okay, again, these are the governing equations because apart from momentum, now we have buoyancy also because we have density gradient also. So you have buoyancy term and those kind of things. So your equation will certainly modify. Okay, so now let's look at some video. Yeah, so see, okay, so if there was no curtain to stop this, then what will happen? The hot air and cold air. So blue is cold, one is cold, one is hot. They are going to mix in the classroom, and this is the experiment which depicts that. So there is hot and cold, and once you stop, you see that this cold current, blue is going this way, the green in this way because of different density. They are going to mix in this way, and this buoyancy force will drive. Okay. Now I want to minimize this mixing because I had put in some energy to cool or hot my room based on the requirement. So how do you minimize? What if I put? So if you put you can put a metal barrier, you can put a door. Okay. But the moment you put a door, that's a physical barrier. Okay? What if my barrier is fluid barrier? Okay, so that people can come in and go out, but then it's barrier for mixing. That's the optimal thing, right? Okay, now you see once you put in air pattern, so this is the separating fluid, separating both, and again this is experiments. Now, as I told you, I do both experiments and simulation, so you can see both here. Okay, and this is when the and now the parameter over here is momentum, what we are giving in the cutter, because it has to oppose this buoyancy force. So you need a strong momentum in this direction, which is going to oppose this. If that is not there, then this separation barrier is not going to be very effective, which you can see both in experiments. And if momentum is sufficient, which is for this case, now you see. Now you see it's effectively separating both. There is slight fluctuation of this, but you see over here in simulation, it's separating both. So there is a fluid barrier which is separating both on both. Both you can see that in experiment. Okay, and this is this, and obviously you can look at the structures and all. We'll look into AD, what is those kind of things. And then we look at, I was telling you can do physics out of it once you have measurement. So from experiments and simulation, now we get into these equations. Now rather than solving it we now have each term. Now we look at contribution of each term. What is turbulence production? What is buoyancy production? How much is transport? Okay. So this is turbulent kinetic energy. Rate of change of turbulent kinetic energy is equal to transport of kinetic energy, transport by pressure, transport by viscosity, and transport by triple constants. And then this is your production of turbulence. This is buoyancy production, and this is dissipation. Okay. We look at now each term separately. If you look at it. Okay. Then we do some very high fidelity simulation. Okay. And this is what you saw at the front, at the title page of simulation. Okay, so now we look at very highly resolved simulation to look at high respect of turbulence, because I was telling you turbulence has a lot of length and time space. That means you need very high simulation to close this problem. So we look at some of these things. And this is the finest scale simulation with which I would like to stop. Okay. So this is what we look at. You see the finest scale. This is the tracer. Blue is the tracer. It's one means it's full tracer, and blue is no, and in between is white fracture. Okay, so these are the high fidelity simulation which we use to understand physics, hidden physics of the problem. Okay. With this, okay, I would like to conclude what I showed in my total of my presentation is turbulence is complex. There are inherent challenges. Okay. There have been a lot of advancement in understanding that you could see that there have been a lot of conflict, but you also see that still there are a lot of challenges. That basically means a lot of challenge means a lot of opportunity for young mind or it's full of opportunities. You need to work on it, and exciting areas. You can impact humanity, you can impact industry, and you can impact our understanding. So you can impact both fundamental understanding, you can impact industrial thing, you can impact bio, because our blood is taken into it. So a lot of these things I work very closely with them, because a lot of our physical insight helps them in designing their system better. Obviously, this job is not done by one man. There is a big army. Okay. Yeah, there are a lot of my advisors with whom I worked in the beginning. Now a lot of collaborators, and certainly a big group of students. Okay. Yeah, so this is my student team, 25 students. This is when my professor visited me. With him, I worked in Cambridge. And obviously, with a big team, you need a lot of money. So there are a lot of funding agencies here, but then yeah, all the funding needs to be. Thank you for your time and question. Yeah, open for questions, Lisa.
Thank you very much, sir. Now, participants, if you have any query, you can ask. I think there is no question from participant side. Okay, because most of them are from computer science background, so probably some these questions suddenly don't stuck in their mind. But yes, this was a very nice and interesting topic. You have very nicely explained that what is the use of large data in turbulence, and basically in any real life problems, if the system is chaotic in nature, chaotic we all know that system is completely disorder and confusing. So for that we need some means a collection of samples, collection of data. With that data, with simulation, we can try to figure out the exact behavior of that system. And using some examples of the classroom, you have very nicely explained. And so thank you very much, sir,
Thank you,
for
Vishal.
your time.
Thanks for invitation.
Thank you,
Yeah,
sir.
lot of computer scientists are also working in this area.
Yes, 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 yes. I know you are working in this field in the Israel. I have visited your lab.
Yeah.
Yes, 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 yes. Okay.
Thank you,
Thank
Vishal.
you very much,
Thanks for
sir.
that.
Okay.
Thank you, everyone. Thank you, all the participants, for your time. Good luck. Do well wherever you are.
Mhm.
Thank you, everyone.
Thank you, everyone. Okay, dear participants, we will start our next session at 2:30 p.m. So see you at 2:30 p.m. Thank you.
How much
Audible?
start?
Ma'am, if you can share your presentation, ma'am.
Okay,
We'll
okay,
check.
okay.
Yes, ma'am.
You can check first, no?
This is visible?
No, ma'am.
No, ma'am, not yet, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
I think fine now. Huh?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Done, ma'am.
Okay.
Okay, we'll start. This also you can start, right?
Ma'am.
Yes. Okay.
Okay. Good afternoon, everyone. Today we have Professor Mamta Dahiya ma'am as our speaker, and Dr. Shilpi ma'am will take the moderation. So, Shilpi ma'am, please
Okay. Thank you so much, Vishal sir.
start.
Good afternoon, one and all present here. Welcome you all. So let me introduce our guest speaker of this session, Dr. Mamta Dahiya ma'am. So Professor Dr. Mamta Dahiya has over 21 years of research experience in academia, industry and research. She is currently working as Professor Department of Computer Science at Manav Rachna International Institute of Research and Studies, Faridabad. She was closely associated with research and development in the field of spatial data retrieval and related security. Building her research in pattern recognition, data science, and information security, focusing on multiple aspects of societal problems. She has almost 85 research publications in various international national journals of repute and conferences. She has multiple Indian and international patents granted and published. She chaired technical sessions in multiple conferences under the umbrella of Elsevier, IEEE, and TQB, etc. She has completed multiple research projects funded by national and international agencies like Optimum Route Planning and Mapping of Sonipat and Gurugram Private Transportation, Government of Haryana, the trend of vegetation cover in NCT Delhi and its effect on thermal environment at an NNRMS sponsored project, Government of India, design and development of a web-based village information system, and currently acting co-PI on technology implementation for water management system in Gurugram, a Department of Science Technology sponsored project in collaboration with SSGD Gurgaon and JNU Delhi. She has recently completed the consultancy on Asian Metropolis Services to carry out the full process of research, analysis, and elaboration of the contents of the publication, Asian Metropolitan Report, with Metropolis, World Association of the Major Metropolises, Barcelona, Spain. Welcome you, ma'am. Platform is yours.
Shilpi, for a wonderful introduction. So I think before start the session, I would like audience, basically who are the audience? I mean, they are the faculty or the students, so that accordingly we can.
Faculties and research
Session.
scholars, ma'am.
Okay, maximum of them the scholars.
Yes, ma'am.
So good afternoon. So I think my screen is clearly visible to you. Today we am speaking.
Yes, ma'am. Yes.
Geospatial analytics integrating with the artificial intelligence. So throughout the, I mean, the last in this FDP, directly, indirectly, you are dealing with the all the concepts that are that is data science. So this is also the one of the very, you can say, the innovative way how we can utilize of the data science in terms of the GeoAI or in the GIS. Nowadays, technically, we call it geospatial analytics. And this is a beautiful term under the geospatial artificial intelligence. So that's why I have selected this topic to just present you in this FDP so that you can put some of the research focus on the GeoAI. So before start the, I mean, session, technically, I would like to how what are the components we are going to supposed to cover during this session. We'll talk about why this technology is important in the current scenario. In how you can identify like your normal data and how this is different from this, and how the geospatial technologies are the integrated part of it, and how you can define that. What are the different platforms, how the analytics are dealing with it, the concept of the GeoAI, and what are the different machine learning models, and they are specifically we are utilizing with the spatial analysis. Simply, what are the different, I mean, the models, they are highly in the practice where the different the words they are using for the different kind of the decision making at the different stakeholders or the bureaucrats. What are the final outcomes, few examples, and definitely the future drivers and the trends in this technology. So first we'll start with, I mean, important everywhere whenever you are dealing with few of the latest magazine, daily newspapers, you will get to know geospatial technologies are highly in demand with the market. And because directly whatever coming in the market, somehow this is job oriented, and the futures perspectives like how this is highly in a demand in the coming future. So you can just go through the different headlines news like how the technology is very important with it. For example, like if you want to work with the geospatial in the Indian market, growth catalyst IPO plans. So this was a big statement in that India by the Map My India directors. Then the Niti Aayog launched geospatial energy map. And before, I mean, just reading these statements or the headlines, might be you are aware about, if you don't have any familiarity with the geospatial technology, in our we are using the application of the Google Map. So Google Map is one of the application where we are taking some positional and the locational basis of the data from the different resources. So you can any application, either you're talking about the IoTs or any smart cities, with the satellites and everything, wherever we are dealing with the GPS and using the facilities of the GPS, using the technologies. So in the broad, if I'll see what is the geospatial technology, this is a combination of the three broad terms. One is there is the remote sensing, another is the GPS. Like by combining these three things, collectively we call it a geospatial technology. So if I'll more focus on the GIS or the spatial analytics, you can utilize on the desktop, web cloud, or the mobile based kind of the services. And only the location specific of I mean any of the data that actually make it different traditional one. Second, if I'll talk about the position, so I think everyone through our mobiles we are using the GPS services, what is your location. So this is basically system. So we do have a different model, different positioning system utilizing that's for the geospatial technologies. Few of them like the GNS, Navic, positioning, surveying, etc. And the third one, if I'll talk about the scanning process, observation, that is through the satellites data, or you can say the remote sensing. So remote, I mean, we are doing the scanning from the remote, so that can be done through the satellite or any kind of manned aerial vehicles, aerial mapping, vehicle mounted, or it can be the, I mean, traditionals, any way from the, I mean, the remote we can sense the data. So the most popular technologies we are using through the satellites, either this is LiDAR and the radar. So again, if I'm talking about the analytics, so here, I mean, normally whenever data analytics, we are trying to find out something insight from the raw data. So here also we the bulk of data from the satellites. Now, how we are interpreting the useful informations out of it. You want to check, just check the, or a train use in the lead cover, what is the forest cover, or maybe the degradation of the forest in the last 10 years or something, how the water bodies are changing over the time. So there can be the n number of the you can say, and how we can utilize that kind of the raw data or the satellite data for the fruitful making at the different level. So here we are having the database with the location specific data. How, I mean, we are just producing and attaching those data with their respective attributes. Like the attributes can be your tree, your any household information, be a street, any river, any road structure. So whatever the information is available on the earth, one, you can see the attribute on the earth. Similarly, how been doing the vector and the raster analysis of those statistical analysis might be, if you are the research scholar, I mean, different kind of image processing. So we are having kind of the static images and we are doing the processing. Few of images can be the raster. Okay, so where we you are simply the using and passing the value in the or false. Simply in the same way we are using the positioning, what I told you. I mean, the another important component GPS, that is talking about the positioning system. So it can be the GPS or integrated with the other geospatial technologies. You can do the indoor positioning, 3D 3 building structure of the geospatial technologies, then the indoor positioning, and it can be again superimposed with some kind of the surveying technique. Like maximum of the civil engineering, they are doing the surveying and they are using those kind of the data for the accuracy purpose, because this is completely depend on what kind of the applications we are using and how the accuracy of your data is important. Might be if I'm using some kind of the application for the defense purposes, then definitely expecting 100%, I mean, the accuracy in that context. So for that purpose, I'm not might be using the GPA. So I am using the better version or the extended version of the GPS, that is called the GPS. That is the differential global positioning system. Because in the GPS only, like from the one devices you are capturing the current location of that particular object, but through the DGPS, there are the two component, one is the rover and one is fixed, that works as in a GPS. So it will give you accuracy in the millimeter. So it completely, I mean, it's up to you, like what kind of dealing with and what kind of the application or the analytics we are doing with it. Now another thing, like talking about the earth observation. So everyone is aware about, like during this, maybe the in the physics we have studied the different spectral, like how we are getting the different source and what is the visible area and something like that. So on the basis of those bands, we have different satellite remote sensing, that can be the multispectrum, hyperspectrum, thermal, integrated by the imaging, I mean, methods, or just that can be captured by the different methods, done the lidars and the radar. This picture, like I have explained, all different kind of the methods here. In the lidar, we are using the light source because every object have a certain intensity to reflect a source of the light. So that intensity will define to help to identify that object. Similar, on the basis of the radar, we are talking about the radiation. Simply the radiation, the wavelength particular object will define to identify and differentiate between the two different objects available on the earth. So panchromatic will give you always gray cells, I mean structure. But sometimes if I want to just simply check the settlement kind of the area, simple forestation, or some kind of the major, I mean, of the water area, or maybe the some other kind of the structure. So these kind of the images can give me the, but if I want to work on the high, resolution data where I have to deal with each and every available on the earth. So in that cases, like I need to deal with the different bands or the different kind of the data to really differentiate either this is a one tree of the mango, or maybe the another tree is with the other kind of the species. For the hyperspectral, these are giving you the different kind of the heat maps, heat bands, and the hyperspectral will give you the different kind of reflection on either this is a vegetation, this is a bare land, or this is some concrete kind of the structures. I mean, on the basis of the requirement of your study and the project, we are going to decide which kind of the or the data you require to analysis. So now we just directly topic, because previously this is all about how it will help you to understand like the geospatial technology, what is the GIS data, why we are calling it the geoinformatics, because only with understanding of the spatial data, then we can do some kind of the analysis and the. So broadly, like for the spatial analysis and the analysis, can perform the two, way to execution of the thing. One is by using the software. That was the, traditional way how we can do the geoanalytics and the spatial. So most popular example I have given here, like the ArcGIS, that is a paid software. QGIS is an open source, then Ilvis, AirDAS, MapInfo, and number of the are available. So through which, like, in fact, ArcGIS is one of the such a popular software that is integrated with the Python. The algorithm, what we are using the Python, that can be directly imbibed to get analysis or the analytics. Plus, you just we can use the same for the machine learning. Simply dedicated domain that is very, popular nowadays in the market, and a huge, area in the coming year, that is the Geo AI. So this is completely clear from the name, like this is the geospatial intelligence. So definitely this is clear, like how traditionally we are using the artificial intelligence on any kind of the data. This can be your machine learning. That can be your medical data. That can be some other. So similarly, like we are using the some kind of the AI concept or the machine learning models for GIS data that can be further used for the computer vision or some different kind of the analytics. Now, this is like how the GIS software, particularly in the example of the ArcGIS, and used for the spatial analytics, means and the analytics used on the geodata or on the spatial images. So this is about, like, if broadly we all aware about is a broad term, then machine learning is a subset of it, then deep learning is a part of learning. So these are the different layers how actually the ArcGIS is there. Individually as an ArcGIS, we can use the multi-layers where the different predictions can be done. But prior to produce any kind of the prediction, we have to digitize your all the maps or any kind of the data that should be transferred into the software. But here nowadays, like what I have already told you, like we are using the some of the standard Python's libraries and some other tools that is that are directly supported by the ArcGIS. Just install or import those libraries for the different kind of the operation or for the analytics. First, these are the few of the example of the Keras, TensorFlow. In fact, in the for the analytics, we are using the GeoPanda. That is one of the most popular library we are using into the Panda for the geospatial. Now, this is the complete structure. Like if in this through the software is working. So suppose just like the traditional data analysis, every time you have to deal with the data. And the most important thing, and further, what kind of the processing algorithm you have, for that, then modeling and visualization. The similarly, like here also, whatever the data you are providing, the images or on the form of the location based data, so that is complete how you are pre-processing your data. So this is a preparing the input feature for your machine. So now our data on the different modeling development model, and this is the prediction. Like this is the one of where it's a case study of one of the Tava country where the accidental prone is easily identified. So this is the traditional way how we are doing it with the Yes, and finally, how the same thing can be done with the help of the machine learning. So this is there is a some road network of a one particular, country to identify accidental prone area. So here, this is the grid. The different nodes are highlighted, and all the layers and the case that are attached with your primary source to your based data or the object, it will give you to help to predict what are the key locations, and you can say these are the highly prone to the accidental. So these kind of the application can be utilized by, you can say, any kind of the bureaucrats or maybe the traffic control police before to nominate different traffic personals in a one particular location. They can take the decision how they have to just impose different facilities or the force over there in that particular area. So the network and the accidents and everything, the things can be done through the project. So this is the like we are doing it through the bus integrating with the your library in the same. This is a plain map over there. When you are imposing the prediction, automatic detection of the different, and it will give you the prediction with the red light lines that are highlighted. These a highly prone zone for the accident. So accordingly, one can take the precautions and the decision for the different kind of the decision making. This is a very important like particularly I'm more interested to explain because many of you people are from the compound, and you are thinking what kind of the research and projects you can carry forward in your life. This is the one of the example. It's like one of the funded project by the government what we have done here. So as science expert, by the nature, so here what we have done, temporal spatial analysis of the complete Aravali channels over the last 50 years. This is the whole reasons of the Aravali channels of the Delhi NCR. So you will see last 50 years of the data. If I'll do the comparison of the different satellite images, so what I have done, it's analysis over the last 50 years. So you will see, here this in the beginning, if you'll see the dotted line is the boundary one. This is showing the 90-kilometer area of a particular water bodies. So see from the 90 square kilometer of the this is a 2022 slides, and this is showing what is current status of representing with the blue lines, how degradation of the resources has been done nowadays. Like it's a different layers of the temporal perform, not only to just study the water bodies, because this is only one example. In the same manner, go the study with your native places, how the urbanization sprawling all over in with the small cities in with respect to what kind of the facility are being provided by the government over there. So it's it's a one of the best analytics tools where the statistics can give you a great insight into the data to propose some solution in this manner. So this is a chain over the data, like how the things are degraded over the time, even basis of the whatever the current scenario, like what are the available resources at the moment. Sustainability models, modelings, and things can be work on the nature. So similarly, you can do the study of the forest. You can apply some kind of analysis through the your spatial data analytics, because earlier can only identify the things by overlaying the images. For example, if I have to check like how a is growing, for example, if I'm residing in Gurgaon, so in the Gurgaon earlier it was a small, but with the time even the boundaries are unlimited. You cannot differentiate where the boundary is from the Delhi, or somehow this is connecting with the some other major cities of the Haryana. At the time the things are changing so rapidly. So those kind of the study we can easily identify temporal data analysis of through the satellite images or something like, or you can propose a method. And we have also generated different kind of the contours, because this is a hilly lovely range. So if we can even propose, if still we can the site So like we can preserve some ponds over there, or maybe the water channels for the future use. And this is the another thing. So if I'm talk about the normal geo class, basically what we are doing, this is my normal, I'm in satellite image. So through the with help of this normal image, satellite image, I can easily identify what is the land cover or the land use classification. For example, in that particular area, you can easily identify this is my residential, this is my upper bare land, this is some kind of the industries are there. So for any as you want to do the some kind of the analysis or the spatial data analysis, you can just overloading. So through a single IMIN system, you can identify how many the residential area, what are the traffic area, what are the green zones are available, and different kind of the planning can be superimposed on them. Now, if I'm talking about the GUI, because to perform such kind of manually is a quite tedious job. Now, everywhere, if I start using the machine learning models to, and for the fast processing, now we need to check like how this is, I mean, the potential with the geospatial thinking. So we clearly state is a field of the computing where intelligent machines are giving human cognitive capabilities and the experience. So here what we have to data, because every day we are receiving the satellite data or maybe the location based data only through the satellite, but even I mean we people are moving with the help of our mobiles, the GPS enabled devices, or maybe they are the IoT based devices or some kind of the other resources. Position and locations are important. So every like this is the data that is growing exponential nowadays. Now, how the advancement of the AI can be integrated with each other, and obviously, if satellite data or the spatial data or the GIS technology are integrated, it means we need computing power for the same. So this is the you can say the momentum that mounting the relevance and the GUI. So finally, if we are integrating this thing, and finally, what kind of the in the future approach that can be lead to us the opportunity of the digital exploit the geolocated data. Second, the how the implementation of the geospatial analytics do, and how we can develop a location based services, like how beautifully Google has utilized. Google has just mapped the all over the world and giving a product as in a Google Earth, and how many different applications. So whosoever the organization or the company, they are using the concept of the Google Earth and overlaying their own services. For example, your Uber, Ola. So these are the best application. So in fact, in the same manner, we have developed our in that is called the Bhuvan. Might be many of you were not aware about it, but Bhuvan is that is a product of the NRSA, that is National Satellite Promotion Agency, but they never utilize the facility because that is not user friendly. But if anybody like who is more interested to use the code data related with in the Indian context, so that is the right resource you can get it from. Now, technically, if I'll talk how we can define, so the main scientist who actually coined the terms of the GUI, it's beautifully defined that of methods or the automated entities that use geospatial data for perceiving, constructing, automating, or the optimizing space in which humans as well as everything safely and efficiently continue their geographically referred activity. So like where nowadays, like we are also doing the geotagging of the wild animals or maybe the rare endangered species, like everything that where you can automate the methods through the machine. So that under the GUI. Similarly, this is this is emerging scientific discipline that combines in the spatial science. So already machine learning methods or the deep learning and the different performance computing we can utilize to extract something useful from the spatial big data. These are the different platform we can, I mean, we are using with the GUI. That is definitely using the GUI data science virtual machine that is called the DSVM. So Microsoft Esri. Esri is the biggest player all over the world that is dealing with the GUI data. NASA is integrating with the Esri. So maximum of the satellite products they are capturing is provided through the to the NASA. So they are working with the different type of the satellite imagery, include the vector and the raster. Similarly, like BigQuery, we are using for the vector only. Intel Geospatial, we are using the raster spatial imagery. For the database, using the cloud Amazon for both kind of the data. And for the quantum, the open source contourism, because the ArcGIS is a paid and a very expensive software, but QGIS is open source and easily available for a common person utility. In fact, also integrated with the Python. Now, if I'm diving deep into the GUI, that so you can utilize the different kind of facilities with the geography and the AI, and you can solve so many problem around you. The unique ability to handle the time and space, and equally more important with the spatial relationship. Now these you just check your all the different kind of the application what I have mentioned in this deck. So we are very much aware about different machine learning or the data science method, how the statistical can be done on the basis of either that might be your supervised or the unsupervised data. So these are the problem, like what kind of the problem we can deal under these kind of the you can methods. So let me see if I just want to check the real time crop some kind of the analysis of the analytics, so we can directly use the regression method in this thing. And if you check the cross and everything, again the same method. But suppose I want to check some kind of the population distribution of the, so here classification can be the another way. Infrastructure can mapping can be also done, because the complete foot captured by the satellite images or some kind of the data that is you are going to attach with the base data as a secondary resource. So in that case also means the data is familiar to you, and you have to in the way how to classify it into the different classes, and you need to some kind of the analysis giving some solution to a prediction of any solution to a problem. Similarly, like if I'm talking about the way how you can identify land cover legends, because that is changes on the daily basis. Because might be in a 1 year back the scenario of any of the city or a village is something different, but with time their land cover and land changes are changing. So you are not even fixed about the things like what satellite you are getting, that is perfectly fine for the thing is or not. Similarly, under the features learning, you can do the geographic text analysis if there is any remote sensing image, well, because that is a very big field in it, because we don't know what you are getting through the image. And so images are large, every feature extraction is very important. But if we train our models in such, so automation can help the hundreds or the thousands of the resources, human resources, a few hours. Similarly, the category under the learning, either you want to set some kind of the routing or the pedestrian behavior and some kind of the building energy optimizations. Few of the example we are taking on dealing with the the problem that is related and correspondingly solution through the GUI. So if I'm doing the same thing in the GUI, like earlier the what I have taken, that is using the ArcGIS, and how Python is integrated with the modeling, we can select some kind of the analytics methods over there. But if I am directly coming my analysis GUI, so it will works in the automation. Like these are the few of the example that the automation system GI already executed in the USA. There is one of the very important project carried out NASA. You might be aware about that is the Earth Observatory System. You know what they are doing? Capturing the different area or the building structures from different locality, and on the base footprints, they are estimating the population of that area. But kind of the study is not feasible in our Indian context, because in the abroad and particularly in the USA, that much planned. One can, if the secondary data is labeled directly indirect, tentative, almost your model will work with the 80 to 90% of the accuracy to predict the population of that land or maybe the residential area. But here, in Indian context, we cannot even thought like a small building can occupy might be the hundreds of the people or maybe to have a so prediction cannot be very much accurate if we are imposing of the matter. So this is one of the method how the GUI basically perform the auto of the detection of the footprints of the building. So here the object extraction, and the solution is the Earth Observatory Factory. Like I don't need to map any kind of the road structure. So with the automation, if you are trained your model will select your different road networks. So this is the one example how the road detection has been done. So this is important applications of the, I mean, data, spatial and data analytics. And similarly, suppose I want some water bodies pattern, some, I mean, rail network, some kind of the electric lines kind of network. So it's completely depend where is my application and how I'm identifying. But this kind of the detection can be done, I mean, through the automatic manner using the machine learning. Another example, sometime it's not possible for a human being to just go through some dense forest and count the trees and their vegetation. Now the technology is such a smart one, like through the maybe the some UAV vehicles or other kind of the resources of the remote sensing. With the satellite, if the satellites are giving you the image with the high resolution, so we can, I mean, easily fire the auto tree counting. In fact, we are capable enough, like complete property of a tree in the, if I am using the LiDAR methodology, then it will tell the canopy, the length of your the tree, their age factor, and there so many, I mean, categorization of the data you can easily identify. So suppose there is a forest and you want to count different species are available in this particular forest, you can easily do with the use of technology. Simply the another, I mean, auto ship. These are the few of the examples that is executed with the help of the AI. Again, here the input is the object extraction and the through the Earth Observatory Factory. So this is like how the auto ship counting do. Another very important, like we are working with the social or some emotion and everything. So if, I mean, everywhere giving the different kind of the emotions, emojis, or some kind of symbols representing that thing through this is one of the example that we are showing. Might be there are some hot topic globally, like how the Russia and Afghan war has carried out, what are the behavior all over the people through the world. So on the basis of that, like location is already attached to your machine. If you are commenting and giving some kind of the feedback to any of the statement, so accordingly those statements will help to predict, I mean, behavior of the human being all over globe, across the globe. So this is the another, like how we classify the emotion based on their geolocations. Another, like if we am talking about the imagery analytics, the another area, different images are there, and on the basis of the multi-spectrum image, it can be near infrared, red and green. Because why just telling why these different spectral images are important, because few of the and objects are very much, I mean, clearly reflected in one range or might be not in another. For example, like through the satellite, normal satellite image, if I'm taking anthropometric image and you're capturing some of the site, so basically what you cannot even differentiate between a cloud and a snow peak hill, because of them are reflecting with the same intensity, and both the object you will they are the same. So there are n number of such kind of the objects that lie on the earth, they have the same frequency, but on the different radiation on the spectrum, they can be easily segregated. It's also the part of your image processing. So here, like this is the PCI geometry solution has given how the training site and segmentation using the object extraction can be easily done. So this is about the different I mean zone through the different layer. Similarly, the training site, like assigning the different classes and final outcome after dissolving the segment over it. So like if I'm dealing with the raster data, it will give you the value only true forms like 0 and 1. But if I'm also attaching the vector segment, you will give get data into a very human understanding where location and the position both are attached with your data. So again, this is the example of the imaginary analytics, and final is the object extraction the satellite. So again, it's completely the what is the purpose of your study. We can the technology and you can utilize the services. Now, and again, the imaginary analytics where the classification is done on the basis of the dense forest, the open forest, and how the forest and shrubs are the classified. So it's not required we need to visit that particular area or something like that, from your desktop, if you do have sources, if you do have the knowledge about the technology, you can do the any kind of the analysis all over the desktop. Now, if I'm taking the example of the GUI on the vector analytics, like this is the one of the example we are using in our routine life, like through the Google Maps. If I want to find out the routes from one place to the another place, so it will we simply need to source and destination, source and the target where you have to move. So automatically your system will give you the different kind of the recommendation. Okay, like this is the more optimum, this is the best route, this is the least route. So I mean, this is a smart application of the AI practice we are using. So they will also alternative like tell you this is the best solution on the basis of different circumstances. Either congestion is there, distance is there, some tolls may be also attached in that particular route. We can take the decision. So the outcome, the combination is its magnitude, how much time it will take, what is the I mean weightage of the average in terms of the road width, constructed material, so that one will either this is a kacha road or pakka road. I mean, how the one can get benefited it. Any legal framework is there? I mean, is there any I mean speed limit where you can travel road only with the 60 km per hour or maybe the more? So those kind of the again weightage averages are also attached with this thing. So what are the current patterns, choice of the vehicle? So multiple options are available on the basis of the AI. You can impose the things. Another component of the vector analysis, like my nowadays few of the people who are developing some kind of the applications, they are using the and the open street map. So this is, I mean, how the open street road maps and the prints can be easily generated. So this is one of the prospective Facebook map they are generating the mapping using the Geo AI. They are already done. So this is, I mean, automatic. They are detecting the different building structures with the Microsoft build here, and on the with this context, different kind of the analysis they can perform on it. Another application you can see in the geo analytics, this is for the defense forces. This is very interesting one, because here the most important thing is it's not only one vehicle is carrying the GPS and only you can track the location GPS. Yes, GPS is the integrated part, but see how the line of sight dynamically change in the position of the observer. So you know, we were the victims during the war, because it was the misuse of the technology. So during that time, basically what was happened, because the satellite captured by the US satellite, and it was openly available one. So basically all the terrorist group have utilized that services, because they were very much aware about the different locations and the post of the Indian movement, and they have taken their post in such a way they were in a clear cut modeling, where they have to just post so that they can easily visualize their movement of all the Indian vehicles and Indian post and everything. So we were in a supervised environment, but in the last, like how we got the victory, we are very much clear. So they have taken the different route from side of the so that they were not able to identify. Now the line of the sight dynamic change. So here, like nowadays, we are very much active with the technology. If there is a accurate data available on the basis of like what is the level of accuracy the satellite images and how we are superimposing those kind of the application, so we easily track the different kind of the movement, and how in fact if you are moving forward, so automatically the observer with the change of the observer and the line of the sight will changes and give you the accurate outcome and the applications accordingly. So this is the another example where we can do the predictive modeling, because this is another very example of the geospatial analytics. Because predictive modeling, just like we are in the traditional data analytics, how the prediction can be done on the basis of this thing. So I've given you one of the study that we have done in the Gurgaon by using the temporal data analysis of 50 years. So this is the another model of the Italy, which I have taken from the NASA. They have done this project. There are some kind of the watersheds in the Bonis. So the hydrology of the different elevated points. So these elevations, you can take any kind of the proposal, like where you have to impose a dam, where you have to create reservoir system, where you can, I mean, divert the channel in case of any casualty. Because in fact, if I'm practically just taking few of the example in our surrounding, every day any city is over flooded with the some kind of you can say uh, uh, some kind of the flood situations. So in during this flood situation, basically what is happening, we are not very much having the clear idea about the what is the different modeling scenario, their elevations point, what is the flow of the water, or some kind of the things. If we do have a landslides, I mean water elevations model, so on the basis of the undulations or the different level of their I mean, the flow of water, the channels, we can just prevent such kind of the situation in the coming future. Similarly, the study can be done, I mean, some kind of the landslide prediction. So landslide prediction is also based on, I mean, because we are having the top view of any of the images. So in the top view, we can easily identify like what kind of the forest is there. If there is a bare land, so automatically, because that is more prone to the landslides, so we can identify those kind of the patches and we can take the decision accordingly. So these kind of the prediction we can easily done. Another, I mean, very important application I would like to focus on. Suppose if we want to identify there is a route network. We say we are going from Chandigarh to the Shimla, or maybe the any, I mean, hill station. So in that case, there are particular, I mean, sharp edges from where we can easily identify these are the area that is more prone to the accident. So like these are the example of the these are the example of the few of the example of you can say the spatial data analytics. Another is the GeoAI, like how the technical environment, how we scholars can work on it. So technological deep diving, I must be focused on the three important part, because here we are more focused with the geo data analytics. So here the big data and analytics is the another big challenge, because here we are dealing with the satellite images. So obviously this is example of the big data analysis that will be, I mean, very voluminous data is there in terms of the variety, in terms of the value and everything. So these are definitely used for the different kind of the advanced prediction, pattern recognition, classification, governance, customer experience, and the deep learning. So what are the, I mean, the future outlook if I'm dealing with it? So if I'm in technology deep diving in terms of the big data analytics, whatever the things are dealing with the traditional data and the analytics in the same manner, all these things are also associated with the spatial data analytics. If big data is involved anywhere, it means these are the new domains we can work on. You are more get connected because location and latitude is position is attached with the things. More personalized information we can do, more accurate prediction we can do, more velocity of the data can be deal with it. So in the same manner, we can work with the quality, then the privacy, security, trust, and the preventing discriminations or the biasness of any of the data. So what does it means for the GI? Now, obviously, this is in the first half, we are just main focusing on the data and the related analytics. But if I'll talk in context with the GUI, so it means you have to work some kind of the advanced gathering of the data flow and the storing of the larger volume, different form of the geodata science you must be aware about, because nowadays we are also capturing the real time data where we need to, I mean, integrate the map with the real time continuous data. For example, what we are doing with the weather forecast, because all the satellites are capturing the data from the remote, and you have to attach your all the primary and the secondary information with the time to provide a better insight and the prediction. So it means like we have to work in the advanced gathering and the other method that particularly focus on only the geospatial data and related analytics. Now the second the step, the technology deep diving, I must be focused is on the massive computing power, because even if a small satellite images I'm just opening on my traditional, I mean, system software, this is going to take so much time. If in the analytics, it completely depends what kind of the analytics you are doing. Either this is related with a small area or a large scale. So definitely, again, it comes to the computing power, how, what is the size of the image, is how different computing functions are involved with it. So it's complete, like you can talk in terms of the speed, volume, and the type of computation. So again, there are the n number of the future look you can talk to solve complex problems in a better way. So there are, I mean, every time we are saying whatever the speed and what kind of the application we are doing. So every, I mean, the computers double, it's required the doubles its chip and the bandwidth approximately every 18 second. So what in this context, if I'll talk like in terms of the computing power, how GI is associated. So as a geospatial data becomes the more accessible and the advanced analytics tool, increase computing power, deeper and a faster inside the large volume and a complex geospatial data. It means we also do have the opportunity where we can work in the computing power or maybe the related terminology where we are dealing with the geospatial data. And secondly, the most important, I mean, environment is the human system integration. So in the human system integration is a field of expertise that pertains to how human interact with the AI. That can be done in the, I mean, various way, because one is capturing nowadays, we are talking about the smart farming. We are ourselves, we can create our own map my, I mean, street, map my log. We can through the Google Earth, I mean, code our location, mark our houses. It means like every day the humans are generating the data. So these are, I mean, how these kind of the applications are just supporting centralized system, how they are integrating to interact with the app, like the smartphones, guided response on the robots, okay? And immersive virtual and augmented mixed reality, because now we are also speaking and talking about the you can say the automatic vehicles. So in the automatic vehicles, so basically what we are doing, automatic vehicles is completely location position based. So driverless vehicle will define like from the one source to the another source how you have to move. So in that condition, again you are dealing with the GPS, and your map should be properly digitized, that will be used by the automatic system. So what will be the outlook in this kind of the human interactions? So it will be the physical reality could be mixed, it can be the virtual or augmented, or maybe the some mixed aspect is there. What kind of the personalized virtual worlds we can deal with? Public services are flexible with the time and the space. So again, there are the huge opportunity if the same thing will be carried out with the help of the GI. So novel way to interact with the gain insight from the geospatial system, virtual reality system for the research, remote robotic system to test and learn from the unfavorable environment. So this is where the things are not possible for the human. Definitely, we are exploring the opportunity to work with the advanced technologies. In the same manner, I mean, all the concept of the future technologies are moving on. So again, the deep learning is again a key task of GIS, because it's a multi-layer data. The traditional way, if I'm only identifying the one layer with the road structure, the another layer, how the plantation has been done, and the third layer, how the residential, the structure footprints are associated with each other. So, I mean, it's completely depend how many layer we are associating with it. If we're talking about, I mean, huge data, so definitely we need to utilize the concept of the deep learning with the task of the GIS. So here we again the philosophy will be remain the same, how the traditional machine learning models we are utilizing for the same. So again, like how we are dealing with traditional data analytics or the machine learning, you need to deal with the data. Here also we need to create a training sample. You need to perform some kind of the inferences to detect the object, or maybe the classify something object in the same of, like if you are taking the satellite images, either this is a car, the different categories of vehicles of the different categories, or the tree of the different species, or the animal of the different type. So you need to, I mean, classify those things. You need to classify the pixel on the basis of the radiation. I mean, what kind of the properties you have received on the property of every pixels. Now, how the post processing is important. So these are the deep model. I mean, how the imagery you are taking to identify on those models, and finally, after applying those model on your images, what kind of the detection you can do. That is also the, I mean, one of the emerging trends or the methods what we are doing in the deep learning processing in the GIS. Now, this is the another thing, how the you can say the relationship between the GUI with the others. Sometimes the people are, I mean, claiming this is not the field with the science, more of people they are, I mean, from the applied science, they are doing the some kind of the dedicated research in their area, or they are using some kind of the GIS software. But this is purely on the computation, because whatever the traditional things are done by the geologists or maybe the geoscientists, geographers, or any kind of the other people who are using the GIS for their relative applications. But everything nowadays we are doing through the automation, role of the machine learning and the analytics are the huge. So in the same context, to check the interrelationship between the GUI with the others. So this is the life cycle of the GUI. Here, if I'm talk about like what are the geospatial cycle of the GUI, and finally, how the geospatial value in the world economy and the society can contribute the different level. It can be the citizen, business, and the government. Now, see, I mean, if I'm talking about the different methods, either this is based on the IoT, AI, cloud, text or the big data. The GIS is giving a roadmap to all the technology. There are the huge, I mean, the scope to work with the things and just lead to your career in this area. So here, Internet of Thing like spatial technology, if we are doing the GIS spatial analysis and we are doing some kind of the earth observation, we are doing the 3D scanning of the any object, if we are doing any kind of the modeling, virtual reality, vision, different facilitators in terms of the standards, open data, interconnected system, we want to impose over the geospatial technology. Now, what kind of processing we are like, the things are very much open to life cycle of this GeoAI. It is very much interdiscipline, and I mean, we can integrate the thing with each other. Now, this is the flow basically. Like this is the traditional we have also discussed in the previous slide. We need to acquire the data, some kind of sensing, I mean, the remote sensing way. It can be your primary, it can be your secondary resource, can be your tertiary resources as well. So geotag data should be there. There should be a satellite images. There can be a point cloud data. So on the of the acquired data, we need to harmonize in the form of we need to process that. If your images are not correct, then you definitely need to process your images. If your tag is not properly mapped or mistagged, then definitely you need to validate your data. And for the point cloud data, we need to generate the training sites. To harmonize the data, again, it means like in layman terms, we are saying this is a process data, how we are doing with the normal phases of the data analytics. We need to some kind of modeling here, but in the Geo AI, we are using the machine learning algorithm for the vector, the raster based on the application of the 2D and 3D. So further in the next slides, we are talking how the technology is defined. So these are the geospatial insight. We get some certain kind of the predictive model, ABI enabled ground testing we can do to make it sure like whatever the result we are getting are up to the mark or not. So might be you do have the question, I mean, what kind of the traditional mode of the machine learning method using? So what kind of the algorithms and the things are associated with the spatial analysis? So if I'm just talking about the regression classification and the clustering. So in the one of the side, we are talking about the conventional machine learning methods, and another what are the popular applications. These are not the limited, these are the only few of the example, I mean, where using the machine learning for the spatial analysis. Suppose linear regressions, decision tree, random forest, gradient boosting regressions, machine k-nearest. So these are the conventional methods. So out of which, if I'm dealing the machine learning with the spatial analysis, we can, I mean, with the empirical Bayesian reasoning, E8K with the independent variables, ordinary squares, geographically weighted regressions, aerial interpolation. In the same manner, classification we do have, I mean, we can utilize the decision tree, random, and the sport. All these algorithms, I mean, sport both the spatial data as well as the conventional method. We can directly apply any of the programming language. You can say the Python or the, I mean, the uh, geospatial statistics used for the same thing. And similarly in the string, like these are the traditional or the conventional methods to do the same. And we are using the dedicated machine learning that is used for the spatial analysis. Multivariance clustering, because here we have to deal with the, I mean, multiple variables at the same time. Spatially constrained multivariant clustering, hotspot analysis. So, I mean, I have given 2, 3 different kind of the example. For example, the accidental prone area, or might be you want to, and you want to analyze how to identify the density of that particular area, density of any particular area, density of any particular area. So, in this case, like in what particular what is the density of the children's, how, I mean, the people who are employed, not employed, male or female, or those kind of, I mean, the things we can do through with the help of the density based monitoring. Then image segmentation, where I have taken the different infrared, red band, and immediately segmented, okay, these are the water bodies, these are the forest area, and these are the different kind. So these things are the different, I mean, example, we are taking the machine learning for the spatial analytics. So another, if I'm talking the example of the conventional machine learning model with the ML model used for the spatial analysis, expectation and the innovation trigger. So this is a Gartner hype cycle for AI, might be as an data science experts. You are aware about how the Gartner hype cycle for the artificial intelligence, and they are more focused. If I'll see the top priority in the Gartner predictions, so the future of the AI GIS is on the top of the priority compared to you will see the artificial intelligence in the traditional and the reinforcement learning, then the decision, the data labeling and the automation services, then AI pass and the auto M. So see, I mean, how the things are. So if I see the peak of the inflated expectation through the period of the Pluto of the productivity, so these are the thing how the technology are I mean concerned with each other. So this is another, like again the geospatial hypercycle will be introduced in 2020, and you will see with the trigger of the technology from the geolobotics with the time up to the Pluto of the productivity. And you will see there are the many of the technology they are dealing with the, I mean, only with the this is a complete geospatial hype. So all the terminology, whatever is mentioned on the map, is directly indirectly is dealing with the geospatial requirement. Either that is related with the big data, that is related with the virtual reality, open, smart city, augmented reality, indoor positioning, or maybe the security through the blockchain and the 3D printing, home automation, because in the home automation also you have to control everything through the IoT on the basis of your location. So I mean, everywhere the concept of the geospatial technology is involved, and you can feel, I mean, what is the scope and how the technology can be utilized in the future. So outcome using these GUI, if I and through the previous example in the technology, so these are the broad, I mean, outcomes you will feel, I mean, how the GI, and these are the only limited one. I mean, we can identify the more outcome on the basis of the problem. So if we want to identify some kind of the image classification, object detection, scene segmentation you want to create, you can simulate something in the artificial environment. You want to interpolate between the two different object or the two different kind of the pattern in the scenario. Time, you know, we are, I mean, identifying some weather patterns from one area to the another. So interpolations can be done and compared through the GIS data. So we can identify the link prediction. We can, I mean, retrace some natural based language kind of the features, integrating with the technology on the fly data integration, like complete air network and the mapping of the air networks all over can be easily done. In fact, directly and indirectly, we are using the technology over there, but there is a lack, still is a lack with the Geo AI. So there are the, I mean, how we can put the things through the automation. Again, the geo enrichment and many more other can be the, I mean, outcome of the GI. These are the only few and popularly like we are using through the map. So this is like on the basis of the example, how the global level adaptation of the GI can be done. This is a server storm forecasting system by the NSSL under the National Oceanic and the Atmospheric Administration. So see, I mean, there are the different type of the layers and the forming. So the people who are expert with some kind of the oceanic or the atmospheric analysis, so they can easily predict the behavior of the different line and the pattern they are expecting to identify through the analysis. Another, like the example how the UNICEF adopted the GUI. This is very popular, I mean, application. Suppose you want to propose, or kind of any level of the bureaucrats want to plan some kind of the planning or impose and identify the current scenario of the thing. So what basically the UNICEF is doing, they are mapping the different facilities all over the area. So, and on the basis of those availability of the resource, they are, I mean, checking the skills and the connectivity of that area to their surrounding locality, and particularly to the particularly to the people who are, I mean, concerned with that kind of thing. So that location based thing can be easily identified, and on the basis of that, like if anybody wants to, I mean, launch a new school, new shopping complex, or maybe the some kind of the store over there, and they can check how many already availability of such kind of the store in that area and what is the population is associated with that, and they can take the decision accordingly. So this is, I mean, another way how we can digitalize it. Now, I mean, how the GI platform they are utilizing with the GI on the basis of the different predictions, and the Spock is developing the comprehensive database and visualizing the platform to the map like the schools and the all the hospital developing countries for the better aid and for any kind of the decision making, like what kind of the example I have already given to you. And in the crux, I'll more this is a very important slide again. This is, you can see the crux of the whole presentation. You can see how the future drive and the trends of the GI. So see how both the horizontal and the vertical line from the low to high are representing the predictability of the trends in medium to the long term trajectory is given. In the simply in the same manner, like the impact on the global geospatial industries are applied here. See, I mean, there are the 5 prevailing drivers and the underlying scent of the trend. They are categorizing of different lines. That is a technological advancement, that is with the green circle, rise of the new data source and the analytical method with the yellow, and the blue with the industrial structural shift, evolution of the use requirement, legislative environment. And see, in the next 5 to 10 years, if I'm taking the column in this last segment, top segment of the high of the both the high segment, maximum of the technology, whatever we are dealing, they are giving you the more focused on with the geoanalytics or some kind of machine learning into that particular field. So, I mean, we can understand what are the new opportunity to gather the data of the GIS data, how the big data processing is dealing with, how the related digital ethics and the privacy is related with, how the urban environment data cubes can be defined, how the real-time information we can deal, and how the machine learning are connecting with the data are the huge requirement and the huge future in the coming. So, I mean, this is the one of the most, and this is the how the geo production AI is associated with each other. These are the trends related with the same, I mean, slides. If I'm looking after the trend in the rise of the new data sources and the analytical methods, either that is related with the high resolution, high revisit Earth observatory data, or that can be outsourcing through the VGI. That is the what are the new opportunities for the data gathering. So every I mean, if I'm talking about these trends, so machine learning and the deep learning disrupt geospatial production. And that will finally lead to the faster information extraction, logs, hardware architecture, reduced cost, lesser human interferences, big data processing will be the normal way. And if I'm talking about the top trends with the new gathering and the big processing, so here we are, I mean, more focused on the digital twins for the modeling simulation prediction and wide undertake of the edge computing here, because edge computing nowadays is very popular, I mean, technology that is dealing with the big data side. So again, I mean, how we are integrating with this machine learning, and the final product will be the smart data and the human info, highlighting sudden change in any of the pattern. I mean, all kind of the pattern you can do, integration of the location and the domain, and how the metadata driven decision you can take. And again, it's dealing with the ethics. So if ethics are, I mean, integrated, then all the digital ethic and the privacies addressed national and the international initiatives are required with the geospatial analytics. So it will predict the socioeconomic results, some kind of the bars of the discrimination rule might be different from the India, or maybe they're different from the other countries. So we need to work on the platform and the universal rule for the global platform. In the same manner, like how the uniformity of the standards will need the data to meet for the time adherence. That is equally important. Sometimes we are, I mean, lacking behind to the technology as the already developed people, country using that. So again, we need to take care of those kind of things and those ethics and the GUI. So what is the next, you can see the opportunities and the challenges for you can see the uptake of AI for the geospatial, because might be when we are talking about the any of the technology, they do have certain kind of the challenges. Obviously there are some kind of the opportunities, but we need to deal with certain kind of the challenges. So we just gone through so many slides to check the opportunities and how the technology is important and how we can impose in our, I mean, future research, or maybe in the project, or just doing anything that is fruitful for the you know, your societal or something like that. So here, I mean, obviously as in a technical people, as an engineers, we are looking more opportunities into this field. So in terms of opportunity, I have already discussed in the three technical main framework here. So somehow in a crux, I can say to conclude the stuff, that is a deeper, new, and a more accurate finding due to the availability and the volume of the data. So almost 80% of the sets are the composed of the geospatial data. If I am talking, whatever the data is available in the market, so directly and indirectly, that is having their geospatial value and the locational value. So, and these are the standard report as were issued by the government. So expected growth of the global geospatial analytics AI market as per to the CAGR report is 23 by 2023. This report was SB Wire was given in 2018, then Garten in 2020. So like in 2020, they are claiming this is 23%, but if I am talking in the current scenario, so we can do the comparison how this is growing into the coming future. So the technology, again, that is technology are the key in accelerating process toward the economy. Definitely that will be the, I mean, you can see one of the asset, how the economy can be generated, revenue can be generated for any country. AI solutions present transformative opportunities to address the global challenge. So these are huge opportunity in everything from data generation to the maintenance to the privacy, the security, imposing the ethics, implementation of the things can be the huge important opportunity. But we obviously need to deal with some kind of the challenges. Now how the you will maintain the interoperability for the public service, because you cannot provide the access to every kind of I mean people, because I have given you the example of the Kargil. The data set was already available with the in public domain. If something is available with the public domain, so anybody can utilize the service, because every resource is very much transparent, publicly available. They do have your, I mean, location and position. So any kind of the, I mean, misuse of the data can be done. Some we need to follow up how the common standard will be maintained throughout the data sets, because nowadays every country do have their own satellites. They are, I mean, imposing the standard, utilizing their services according. So we need to work, I mean, globally for some kind of the common standard, so utility can be done at the same pace. Now the another point is the regulation. How the protection, data protection, privacy, liability, and the discrimination coupled for the large vacancies of the adaptation. And now the human, I mean, dimensions of the trustworthiness is a key prerequisite for the AI uptake, because might be it's a, I mean, the drawback of the machine. We are claiming the prediction of the models. We are claiming, okay, my model is giving the 95% of the accuracy. It's not like how your model is working, but the important is on which data you have trained your model, what is the authenticity of your data, how the data is valuable to each other. So we need to, I mean, we need to trust some kind of the dimension, and how we can be trustworthy on the GUI to take some certain kind of the, I mean, dedicated or the delegated decision. So I mean, this is all about I would like to see what we have done the geosciences. So this is personally I feel very interesting area, and we there are huge way how we can, I mean, look for the research opportunities and some kind of the funding projects, and some kind of, I mean, how the innovation we can integrate it with the machine learning with the available, I think, the software. So I hope Dr. Shilpi, I'm happy to take the questions now.
Yes, ma'am. But in our chat section, we have
Because this is, I
not
mean,
yet.
the
Yes,
one-way
ma'am.
communication first.
Yes, ma'am.
It's
Yes, ma'am.
better to spend more time with the questions.
Yes, ma'am. So we are not getting any questions from participants yet, ma'am. So from my side, ma'am, the session was very informative. Today, we got an opportunity to hear your thoughts, and this will surely be going to encourage our participants in their future work to develop their skill in this area. So you have discussed this topic in a very effective way from basics to in detail with lots of example. You have discussed about geospatial technologies, platform, geospatial analytics, geospatial artificial intelligence, and application of geo AI like imagery analytics, vector analytics, prediction, which we use very frequently while using GMAP. So you have also discussed about geo technical environment, what machine learning methods we can use for a spatial analysis, a spatial explicit model, GeoI life cycle, and benefits of using GeoI. You also presented the opportunities and recent trends of Geo AI, where we as a researcher have lots of scope to give our own inputs. So ma'am, on behalf of our department, Amity School of Engineering and Technology, I extend a really hearty vote of thanks to you who spread time for time from her busiest schedule to grace this event, but also for enlightening our participants with your commendable talk on this particular topic. So finally, I would like to thank all the participants present here for joining this session. Thank you one and all. Thank you so much, ma'am, once again for accepting our invitation, ma'am. Thank you so much.
Thank you, Dr. Shilpi and Dr. Vishal for giving the opportunity for this thing. I'm open to have your question ever in the future, because this is the area where personally I
Yes,
feel
ma'am,
are the huge
definitely,
opportunity,
ma'am.
and there are very limited, I mean, the stakeholders who are working the field, and the people who are, I mean, working with this thing or this kind of platform. So they are open to take my help. You do already have my, I mean.
Yes, ma'am, and I will share with them.
So
yes,
surely. So thank you, everyone.
Thank you so
Dr.
much.
Shilpi.
Thank you so much.
Thank you.
Hi, Trupti, ma'am. Hello. Participants, our next session will be at 5:30. So be connected with us.
Sneha, can you share your PPT? एक लैपटॉप चलता रहेगा अभी ऑफ की माइक अब सही है दिख रहा है हमारा डेट है 7 और 8 दिसंबर में
Good evening, everyone. Welcome to today's last session. We have our speaker, Dr. Snehasis Banerjee, and Dr. Pritish Ranjan will be the moderator of this session. Pritish sir, please take the session.
Thank you, Vishal. Good evening, everyone. I'm Dr. Pritish, and thanks for being connected in this session. It's my pleasure to introduce today's speaker. Let me introduce Dr. Banerjee. He has 13.5 years industry experience. He is a lead research scientist at TCS Research, and he is also contributing as a guest faculty at CSC department at IIIT Guwahati. He is a senior member of ACM, IEEE, CSI, and lifetime member of IETE. He has done ME from Jadavpur University, and he is a PhD fellow from IIIT Hyderabad. His research or his expertise is in cognitive robotics, artificial intelligence, machine learning, data science. He has received many awards. He is He has received CSI Young IT Professional Awards. He is a winner of ACM IEEE ICSE Prize sponsored by Monash University 2019. He has also got the, I think, Best Paper Award in TCS Technique Analytics Symposium in 2015. So with this word, I would like to invite Dr. Banerjee to give his talk. Dr. Banerjee, please, over to you.
So I'm sharing my screen. My screen is visible, right?
It's feasible, sir. Please. Yeah, everything is fine. Please move ahead.
Okay. So today I will talk a little bit about data science, just to give an overview, and then we will show some hands-on what is Weka, where to use it, Weka, and other things. So, like this. So, due to lack of time, I am skipping some content. So,
No
I
problem.
am from TCS Research. So, in TCS Research, I personally work on the cognitive robotics field. There are multiple other things where we work on. As you can see, compared to another company, we are not totally focused on computer science. There is scope for other engineering backgrounds as well, because there is mostly cross-disciplinary work that we do. And these are some of the projects in which I am currently involved in cognitive robotics, where we build more on the software part of a robot, the software that runs on a robot, and that requires almost all parts of AI and live data analysis. Similarly, there is a group that works on visual computing, like where the data is image and video, and on that we can do multiple things like virtual try-on and mimicking faces, creating deep fakes, AR, VR, and like that. So we'll just quickly go like to understand like what is a model, because this is important to understand data science. And whenever when we are going to deal with Weka or any other tool, that is the thing that we are going to deal. So anybody can say like what is a model? Someone can maybe point out. Any answers?
I think model is a blueprint to represent something.
Can you give some examples?
A person walking in a ramp is said to be a model, I think. Example. So why is said to be a model? Because he or she is a blueprint for somebody in the society.
So fashion model, like that.
Yeah, fashion
Yes.
model.
Yes. So basically a model is a general set of abstraction. So because the world that we deal with is quantum, so it's not possible for a normal human being to talk with each other and tell that, okay, this particular atom is at this coordinate system. So we usually talk as a whole. So we have found out this thing called model, which is a good way to communicate with each other concepts. As an example, okay, so this is coming to my screen all the time. So 3 people. So can somebody take care of this? That is, whenever somebody is entering, please admit immediately. Yeah. So that's why when we are trying to describe even Earth, initially it was thought of as a sphere. Then it was told, okay, let's call it an oblate spheroid. And then finally we could not find anything to describe Earth. So we called it geoid. Geoid means it's Earth shaped.
Dr. Banerjee, sorry to interrupt you.
Yes, please.
But Dr. Banerjee, your voice is not clear. It's murmuring. So can you check your headphone if some issue might be there?
Yes, I will just keep the microphone close. Now it is clear, right?
Somewhat clear, but okay.
Okay. Yeah, so I will just speak a bit loud then. Okay.
Okay, no problem. Please continue.
Yeah, so now it is clear, right? The voice?
Somewhat more clear than that of before.
Okay, fine. So some of the examples are equation, graphs, which can be from geometry, statistical, and so on. And so when we are dealing with any model in computer science, we are limited by certain things, like there are some physical constants, like how can we represent something. So in computing, there are only 3 operations that we can do. One is if, second is assignment, equals, and finally while loop, for loop, iteration. So in computer science, we cannot do anything apart from this. So these are the atomic building blocks. So if we have to build a model, it will be based on this only. So there is no other way you can build a model in computer science apart from reusing these 3 operations and the data itself. So one simple example is that you can write a code that says if a number is positive or not. So this can be thought of as a model. This is an equation, but it is also a model that when data comes in, there is some check and then it says plus, it's minus. Now, suppose we say that this is X and this is Y. And in between, whatever is there, we call as model F.
Again, sorry to interrupt you, Debashish. Your PPT is not shared, I think.
Huh? Oh. Oh. Now it is there now?
Yeah. Please go ahead.
So anyway. Yeah, so again, just iterating. So in computer science, we are binded by this comparison, assignment, and iteration. And even this can be thought of as a simple model. And I was here. So when there is an input variable X and then output variable Y, something is happening in between. That is what we call as a model. Now, this can be some if-then statement. This can be some estimate. There can be many things. So one of them can be like this. So in earlier case, this F was known. I am setting that X is greater than 0, then what will be the Y? Now, what if the F is itself is not known? In that case, you have this X input variable, you have the output variable. Then how can we estimate F? And you have some data like this. These are the X and these are the Y. So for this set of examples, there are many answers. So there is no single model. There can be multiple answers. Now, which one will work? Which one to choose? How do we decide that? And that is what statistical modeling or modeling theories are all about. And this is the essence of data science. So this model that everybody talks in data science or even in machine learning. So the model works on some data, and the science is to identify like what the model is. And like there are 3 things. So even if you think simply, what can happen? So the science will deal with what the model is, what type of data we need to handle, and what cleaning and other things. With what can we do on X before feeding into the model? And once we get the Y, the output, what can we do with that? That is the decision or analysis, whatever. So these three things are the main components of data science. All other things are around the jargon around these things. Now, again, when we are dealing with model, let's take this example. Sometime back, there was an idea that there was some news that TCA that there was an end of Earth event going to happen, and an asteroid called Apophis is going to collide with Earth. And similar to Richter scale, there is a Torino scale. So in 2005, 2010, the scale was quite high. So NASA told that it's going to hit Earth. So if it was the case, then we should not be listening to this lecture, right? We should be trying to solve this problem. But later it was found that it's not going to hit Earth. Just recently, a few years back, it was told to be so. So, like what changed? And this is a very important problem that you can understand, that is life and death. If it is a data science problem, like this is the problem. So it was found that the estimates that were made were a bit wrong, and mainly because of the models that were built. So human minds cannot process large data to form models. They have to delegate this to some machines. Models that are true today can be replaced by better models, because again, as I told, that there can be multiple ways in which these X and Y can be interpreted. And better models, how are they formed? There are only three ways. One is when you get more data to substantiate. If we had more X and Y, we could have narrowed down which might be the model. And if we have some better algorithms, again, what is the algorithm here? It is how to process the X, clean the X, reformat the X, the input, what type of algorithm, general algorithm you want to use, like neural network, SVM, whatever, to represent the model. And finally, doing with the output what you want to do. What is the estimate? What type of confidence interval level estimate you are going to make. And third is the experiment design. So when you are trying to estimate something or predict something, there are many assumptions that are made. Were there any wrong assumptions made? So statistical models can be really 100% accurate in practice. That is the main take. Again, I will just quickly go through this. Like what is intelligence and other things. Oh. So in the quest of this data science, or trying to mimic a little bit of human intelligence to some models, the scientists found that games might be a good way to take care of this challenge. That is, when you have to prove something, do it in the virtual world and see whether a computer can beat humans in some things. So that's why checkers, chess, Watson, and now Go game. So these are still limited to like where the intelligence part is. But due to lack of time, I will skip this. I will just move to the. So if you look at the current usage of data science, you will see that it is used in algorithm trading, in financial advising. That is, in India, it's not much in practice, but in European and US, it is quite a lot in practice. Advising where to invest your money. Content writing by gathering data and applying it. Then you can do some disease diagnostics, because it has been found that for MRI, X-rays, the data analysis engines are much better than doctors. It is already proven. And there are many other things that you can do about it. Now we come to an important part of the slide. So in the earlier days, when the scientific reasoning mind got evolved, so what we used to do is experimental science. We try to describe a natural phenomena by doing some experiments. Like, okay, if I put certain balls. If I drop it, it will fall. If I maybe if there is a if the wheel shaped things can have less friction, or it was easy to move things when they're put on wheels rather than putting on square shaped things. So through higher experiments, we have to derive something. So in this case, the problem was identified, that this is the problem I want to solve, and through experiments I am trying to solve the problem. Next, for the same problems, theoretical science came, that can you map the model, map the current, whatever I am experimenting in the physical world, to some simple equations and representation of the real world using mathematics. So in that way, the theoretical science came, where we want to represent the model. And then, because it was becoming much more complex to represent the entire world or some certain phenomena in the world, just in terms of mathematical equations, then came computational science. That is, you run simulation in the machine, and then you can decide like what might be the models. So all the quest was, there was a problem. You are gathering data around it, and either doing some experiments, doing some mathematics, or giving it to a computer to churn out whatever reasoning you want to do. So in all the three cases, the problem was known. Now, what has happened with the data science, which is called the fourth data paradigm or the e-science. So it is not the problem that is the main thing. It is that you have a large amount of data. With that data, what type of problems you can solve. So there is a shift in the equation. In the earlier days, you were trying to find solutions to known problems. In this case, you have large amount of data. What problems you can solve with this data? So the focus is more on the Y part. What output you can get. If there was an X, model F and Y, well, you already have X, you already have some Y, but after Y, what can you do? And for that, what models you need? So this is the current data science that everybody is nowadays talking about. I will just quickly go through these things. Yeah, this is, so there are some definitions of machine learning that you can come across. Like if you look at books, Tom Mitchell book has these. There is a Jutia Parler book that will have these, and so on. So I will not give you these definitions. I will give you a more generic definition, which is automated model discovery. So this is going to get us near to intelligence. Why? So let's take the example of an exam in your own college, MIT. And this is a multiple choice question, and there are 4 options: A, B, C, D. Now the students have started to write the exam, and one of the guys, suppose me, I am one of the students. So the first question I don't know, right? What should be the answer? It can be A, B, C, D. So I'm making a guess. It might be B. So I make a guess and answer it. I see that the other guy just peek around here and there and see the other 2 guys, I can see they have also marked B. So then probably it becomes an educated guess or a hypothesis. Probably B might be the correct answer because the other 2 guys, they might be wrong, but they have also marked. So I do mark B in all the answers, and I get very good marks. That is, B is the input X, and the good marks is the output Y. So we get a model that in Amity Patna, if we give answer B in the multiple choice questions, all B's will get good marks. So that is the model that works in here. Now we see that all the courses and all the curriculum that is taught in Patna region or MIT, I am getting very good marks. Then it becomes a theory. Now if it was found that not only this Patna region or India, like all examinations we are giving in this domain, I am getting good marks in all colleges, then it becomes a law, because that is what we are observing in the real world. So there are 2 other things as we are going towards truth. One is the theorem, another is the axiom. So axiom is something that you cannot challenge. Theorem is something that is derived from the axiom. So this line actually is the division line between mathematics and the real world. So in statistics, you will see that you can prove many things, but mathematics has some fundamental axioms that you cannot challenge. That's why it's not exactly applicable in the real world as it is. But there is no other way also. You have to use statistics or mathematics in some sense. So we have to, whatever we want to do in the real world, it has to deal with this. So as of now, we are stuck here. So we have some data, and using the data, we are trying to predict some models. So machine learning model, if you want to say, so what we are doing is we are giving data to a general algorithm. And the general algorithm is outputting a special algorithm for that data. So this you can think as a mother algorithm. You're feeding this data, it will give you a special algorithm that will work for that type of data. So this is like some form of representation structure. You can also write it in this way. That we have in the normal computer programming, what we do, we give data, we write the program, and the computer gives the output. But in the machine learning, you give data and the output, and the computer gives you the program. So that next time you give the data, it will give the output. So it is basically learning the model. And there are basically 3 parts of learning. So whenever using some modeling technique, there are 3 parts. One is representation. How do you represent your model and the data space? How do you evaluate that your model is good? How do you evaluate? You give multiple hypotheses, and one of the hypotheses you find to be correct or more or less correct. And you also have to do some optimization. Optimization has different levels. One of them is if there are multiple hypotheses, which one to converge. And also you can have something like computational cost and such things. How can you optimize? So the example of representation is like this. Suppose this is the data that you want to separate. This is in Cartesian coordinates, as you can see. So like a simple way is just to transform it in the polar coordinates, and this data will get separated. Visually at least, not maybe in the coding way, but visually it will get separated. So that's showing a powerful example of how representation matters. And there are many ways in which you can form a hypothesis. You can feed it to a decision tree, rules, graphical models, neural networks, support vector machine, and so on. Now, how do you evaluate the hypothesis? Once you make a hypothesis, how do you evaluate it? There can be accuracy, precision, recall, squared error, likelihood, postural probability, and so on. And finally, optimization. How to tune the hypothesis to a suitable one, which is acceptable. And there are many ways, like combinatorial optimization, convex optimization, and constant linear programming. So let's now interact for a simple use case. So suppose this is the problem, like based on picture, state whether an animal is cat or snake. And these are the hypotheses. There are 5 hypotheses because computer science guys start with 0. And now your brain is the A for model. So this data is getting inputted into your brain. What is your brain going to churn out? So somebody please answer. Like, what do you think? Which hypothesis is good? Seems to be okay for this problem. Like snakes are long, cats are short, cats have ears, snakes do not. Cats have legs, snakes do not. Cats have short tails, snakes have long tail. Snake sound is his, cats is meow. What is your final hypothesis? Any answers? Yeah, am I audible?
Yes,
Yes, sir, it's audible.
Okay. Hope, like if you are trying to solve this problem, whatever is going on in your brain is exactly what happens in this modeling. That is, you are looking at the hypothesis. The input space is text because you are reading the text, and then you are putting this text into some higher dimensional space, and then evaluating that which hypothesis matches the problem, and then trying to close down on a particular hypothesis, canceling the other alternatives. That is the optimization part. And that is exactly what happens when you are doing machine learning. So what is the final hypothesis? What do you think for this problem? Any idea? Yeah, is anything coming in the chat? I cannot see. Or like what?
Nobody has.
Usually the students are very responsive to this question. I don't know why students are watching movies or what. That is one of the problems in this virtual mode. So this is a very fundamental question, as you can as we will show quickly. So I'm reiterating the problem, like based on picture, state whether an animal is cat or snake. So just name a hypothesis and why you are thinking that it is the best hypothesis. So this is exactly what is you are going to do if you are trying to solve a data science problem. You will have multiple hypotheses and you have to select which one is good. And you give machine learning to do it for you. But because your brain is incapable to do that, if the data is large. But here the data set is small. At least the number of models I have restricted. So any idea?
Are animals.
So like based on the picture, you have to state whether an animal is a cat or snake. So you're given a picture and you have to state whether that is a cat or snake. So what is the an input image is coming? There is some model, one of these models. An output cat or snake will come as output. Which one do you think is good to do that? For example, I will give you some hints. Like for example, the hypothesis 4 will not work because the input is a picture. The data format is picture, and here we are talking about audio. So this is a wrong hypothesis. This is cancelled out. And the rest 4. Okay, due to paucity of time, I will not waste any more time here. See, these snakes are long, cats are short. This is good if your data set is like that. Like in the data set, your snakes, the pictures of the snakes are long. The cat images, the cats are being short, then it's fine. But if in the images data set that you have, the snakes are a bit like in a large field or a football ground, here there is a snake. Then the snake might be long, but in the image it is short. So then this hypothesis will not work. Hypothesis 1 also, cats have ears, snakes do not. So if the image of the cat does not have ear at all, that is, it is a very front, like only this portion is covered, then also this hypothesis one will not work. And hypothesis two, like cats have legs, snakes do not. That is also the same thing. Like if the cat's legs are in the image, then it will work. If the cat's legs are not there, it will not work. 3, short tail, long tail. Again, it depends like how the image is captured. So what has been found? So each of these hypotheses is true under certain conditions, and it is false under certain conditions. So your final hypothesis will be a combination of 0, 1, 2, 3, a weighted combination. It will be not be in one and only, and it will be totally what will decide the weight. The weight will be decided by the data that you feed to the model at the training time.
I think if the tail of the cat machine can get confused while seeing the tail of the cat, that it can be like a snake.
That is possible.
That is also possible.
That is also possible. So
what kind of model, if I get this kind of data, then what kind of model you really suggest?
Yeah, so basically what we are doing is some features. What exactly we are looking for are these called features. These are all features. So when you are giving a, there is some like talk. Yeah, so when you're giving a data set for classification or whatever other task you might want to do, a normal standard technique is to use feature extraction initially. These are like high-level features. They used to detect leg, but more often it's not required to detect those high-level features. You can just deal with low-level features and then decide like which features or in the image which features are important and which features are not, using feature selection. And then it can be fed into any type of model. That's right. Whatever like model means, like if you want a representation in VM neural network, whatever. So what has been done here is basically so each of these hypotheses deals with some features. So these are an amalgamation of features that will give you the final model. These are some standard things. Classification. If you can divide the field into multiple parts just based on the output, what is there is a y, what you get. If you get a if you get a discrete set, if you get a discrete set of output, then it is classification. If you get numeric value, then it's regression, and when you're doing with categories, then it's cluster. So this is everybody like knows. And basically there are 5 general types of model that you can apply. For example, if you are trying to find support vector machines, so that is the representation. The evaluation will be based on the margin, how good a margin you get, and the technique is a constant optimization, like that. For neural network, it will be the mean squared error of the loss, and gradient descent is the optimizer. So, the field of machine learning has been divided into this in 5 parts in terms of representation, optimization, and evaluation. So you can select any one of them depending on the problem type. So each one has a reason, like when to apply, when not to apply. We will not go into this because it's out of scope. Okay, so I will now going to go to the show something in the AI model.
Yeah, Snehasis.
Yes.
I think your talk is This much. Are
No,
you
no,
winding up?
I'm showing the Weka tool. I will show now the
Okay,
Weka tool.
okay. Please go.
Yeah, so sharing my screen. My entire screen is has visible now. My entire screen is visible, right? Hello?
Yeah, visible. Yes, yes.
Yeah. Yeah, so there is a tool called Weka. So what you do is you can download it from the website. So if I go to just if you should just type Weka, then you can go to this link and then download. There is also a book and some courses that you can use. So like when to use Weka, when not to use before going into the software. So the idea is that when you are doing a production level thing in industry, then nowadays you can directly use Python. And your ID should be like a PyCharm or maybe Spider, something like that. You can have a set of a Conda environment and accordingly do that. But if you are trying to like do some simple experiment, trying to teach something quickly and make the student understand what is feature selection, what should I do with the data, then Weka is a good starting tool. Because many of the things you can visualize, whereas in Python you have to understand the code. There is not much visualization. You have to import some libraries. So there is no straightforward thing. So here, I'm closing this. So we are so because it is based on Java, so you have to use this Java -jar and then weka.jar. So it comes as a jar file, which also has other dependencies. So when you type Java -jar, weka.jar, it will load the jar as well as other related jar files from the folder. And the initial interface will look like this. This is the Weka GUI chooser, as you can see. And there will be many things. There should be something called memory usage because it's based on JVM. There is visualization, different types of visualization, and there are many types of tools. Now, an important thing to note is that whereas in dataset, I don't know what has been taught in the earlier, but I hope that you have been taught training set, trace set, what are class levels. So there is a particular format that Weka follows. So you have to follow that, or you can, if you have data in another format, you have to convert to ARFF. So there are some software available to convert into ARFF format.
I think Weka text CSV also, I think.
Yes, CSV also, but then you have to annotate the things that what is the level and class like that. Yes.
We need to just adjust the format.
Yeah, adjust the format, yes. So if we just open this. So it is directly from the website. So basically, if you look here, so in the Weka format, all these files, I am showing the data set, what is the input. So this is a comment, this percent sign. And in the first, you have to write something called relation, which means what is the data set about, something like that. You can write anything you want. You can also write your name, does not matter. This is just a simple header. And after that, you have to write the attributes. What are your features? What is the features you are dealing with? This is the iris data set. And these are the features, like what is the sepal length, sepal width, and so on. And you have to also specify the data type. There is a specific data type that Weka can handle. There you can also find what are the types of data it handles, categorical, numeric, like that. And the last thing, so you can have as many attributes you want. And the last thing should be your class. This is also written as an attribute, but the way Weka handles it is that whatever is the last row under the attribute, it will take as the class. And how many classes it has, it will know by just seeing how many elements it has. If there are 4 classes, there should be 4 elements. If there are 2 classes, this one should not be there, only 2. So it automatically understands that how many classes are there by just reading this thing. So that is one. After that, you have to use this annotation data. And this data is the one similar to what you have, like in your if you are handling with CSV file. So this is how the CSV file will look like. Like some columns. Initially in CSV, what happens? The columns will be on the top, followed by the data. But in this case, the column headers are here. So this should be here. This relates to this one. This relates to this one, and so on. So in a CSV file, usually the first row, the header contains the features, but here you have to declare the things initially, and then it will automatically map. And the last thing is the class, and this class value has to be one of these, otherwise it will give some error. One of this set. You can also write 0, 1, 2, if that is also fine. Then you have to write 0, 1, 2 also here. So these are the three things. One is the relation. This is just a formality. If you want to write some comments, use the %, each of the attributes, the name of the attributes, what is the type, the class, and the number of possible members of the class. And the same thing you have to repeat in the data as well, where your data values are there, followed by the class level. So now going back to the ID. So I am going to the Explorer, and I am clicking Open File. So when you are opening this, I have just opened a file. It will automatically show this visualization of the values, the ranges of the values. For example, this is the feature preg. This is the feature class, the skin type, like that. So this will give and the age. Age will be more easier to relate to, and finally the class. So as you can see, this is an imbalanced data set. So there are some 500 negative classes, and this is 268 positive classes. So whereas in Python, suppose I am giving you this data. So it's difficult to just look at this and see what is this about. But using Weka, you can directly get a glimpse for each of these features, what is there. And then you have to select all this. You can select all, you can select a few, whatever you want to check. So as I'm selecting all. And then you can do many types of filters here. Like if you want to do some maybe changing the values from numeric to some particular class, like what maybe resampling the data set. So there are many data attributes that you can do. Maybe you can want to do some mean, median, average, something like that. You want to solve value. So there are many things that are standard functions that you can just add and it will work. And then you can do classify. And in the if you just want to classify, like whether what type of problem is this, because there are two classes. This is a binary classification problem because there are only two classes, tested negative or tested positive. If you click classify, you can choose different types of models. Again, these are representations. If you remember, there are three parts in a machine learning: representation, evaluation, optimization. And then you can select a decision tree, or here there is some terminology. So these guys have used some old annotations which were used, like J48 is a random forest. So in the earlier days, so each of these algorithm has some name, so they have used this. Then there are SVM should be under meta or something functions, base SVM. So even in SVM there are something called SMO. So it is something like a version of SVM which converges quickly. There is multi-layer perceptron and so on. So just let me select this. Maybe I will select J48 because it good result. I'm selecting this, and I am doing cross validation. As you have already been taught, we cannot just use like training on testing, training. Then we'll get good results. We don't want that, right? You can also do that because it will give you some cues that how much data is the imbalance is what, how much things you need to do on the features. So even when you are testing on training, you will get some insights. That's what is the maximum possibility. For example, even in the training data set, you are getting 80% accuracy. And if you have not done this earlier, and you are, suppose you're getting 75%, you will might be thinking, okay, my accuracy is not that good. I am getting a testing accuracy 75%. But on that data set, even if you use the training data set, then you are getting 80%. So it's a good thing to just have a check that even in the ideal condition, how much you can get. So there are many ways in this can be done. Percentage split is that you split the data into train and test, 66% test, train, and 33% test, like that. Popular thing is to use cross validation. You split the data into folds, pieces, random sampling, and then you report the result across 5 folds and then average it out. And you will report this against a particular class variable. If I click start, so it will immediately give you all the confusion matrix. This is basically a confusion matrix type of thing, and all the scores like precision, recall, other things instantly. And these are the things that you repair for reports and other things. These are also possible using Python, MATLAB, but you can play around so quickly, right? Otherwise, you have to go to a code and change something. But here you can do it so quickly. There are many parameters you can say, like what is the depth of the tree, another thing. Now, if I select another, I select naive Bayes. Naive Bayes, you might be knowing, it's a very fast because it handles probabilities. It's very fast in computation. So how much accuracy I got here? What is okay? Then another thing is that precision recall might be biased. It is always good to look at the AF measure to get a good idea, and also the ROC curve. The AF measure I got around maybe this 0.77, like that. So let's see whether we get it worse or better here. So you've seen that we are getting a better AF measure in this case when we're using name base. Then probably the data follows some distribution. That is why it is happening. Distribution means it follows normal distribution because name base is based on normal distribution. You can also try maybe support vector machine. Let's see what we get. Oh, we are getting a bit more higher. The good thing is that you can also see this. So this is 824, this is 836. So there is some significance. So we can also side by side compare. Instead of running the code and writing it down, it does it. So initially, when you're trying to find which representation you want to work with, you can use this one. And then when you decide, okay, SVM is working fine, then you go to these parameters, like what should be the C value. So I also have some slides on SVM, which I will not show. So in SVM, there is a C value, which decides the misclassification rate. That is how much misclassification you can allow. And another one is the epsilon. This one. This shows the density. That is how much area your hypersphere or hyperspace should be covering. So there are mainly two values in SVM parameters that you can tweak. So this you can change and see whether you are getting the result. But when you are trying to compare this, you can compare different types of representations and see that, okay, finalize. Okay, this one I should focus on. Because changing a little bit parameter will not have a drastic difference. It's not like you are using naive Bayes, you do multiple fine tunings. Sorry, you are using J48 and you're doing multiple fine tuning, that will be able to beat suddenly this high measure of SM or SVM. That is not going to help. So this will give an indication that for this data set, which thing to use. Similarly, you have clustering. If you want, so in that clustering, the label will not be there. So try based on just the data you want to do in an unsupervised way, you want to form clusters. And in clusterings, either you can use specify the number of clusters, or you can also use some techniques called C-load coefficient, which are cluster quality metrics, through which you can know what might be the ideal cluster. though knowing the ideal cluster is still an open challenge, but some statistical understanding you can have. So in simple k-means, you can specify like how many clusters you want, but you can specify the number of clusters here is 2. Because the data set already know there are 2 classes, that's why you can change it. The data, it can also form 4 clusters, whatever you want. And there are other things like there should be EM. Where is EM? Yeah. EM is there. And apart from that, hierarchical clustering is there. The DB density-based clustering is also a technique how it's like a wildfire. How does a wildfire of the density spreads? So these are the mostly used. Either you use EM, which is mostly based on the probability. The EM is the expectation maximization. You can use the density-based clustering or the simple k-means. There is also a variant called c-means, which is not there, but some add-ons and Weka are there. You can also use. There is something called association rule mining. Those things can also be used here. And also you can select like which attributes are good. So you can basically do a feature selection. You're giving so many attributes here. See so many attributes. You can also select which attributes are. It will list down like which attributes are good. And finally, you can also visualize the data distribution of the values of the data. Yeah. So overall, like it is a good tool. Like if you want to immediately get a look of the data and get an understanding that where I should invest my time, you can get the good attributes from here. You can find some idea what clusters are there in the data. And
Dr. Banerjee, sorry to interrupt you. So when we use select attributes,
yes,
we get the rank, isn't it?
Yeah, we'll get the rank.
But we do not get who is at rank 1. How it gives the numeric value, but which attribute is actually at rank 1? How can we know when we use Weka? If you can use some data set and say how the feature selection work in Weka, then it will be helpful for our students.
So this is there is not much time, so I will say in this way. So this specific problem, that is which thing is rank 1, we cannot say because it's a statistically unsolved problem. I am telling why.
Okay.
The reason is that one feature alone does not contribute.
Yes.
It is the combination of feature that gives a higher result. And a specific combination. It is not like I am saying that 1, 2, 3, this is giving good result. But it might be the case 1, 2, 3 is giving individually good result. But 4, 5, 6, when they come together, they actually complement each other's fallacies.
Okay.
So if, suppose there are 10 features. So what are the number of combinations possible? All combinations, right? 2 to the power 10, exponential.
10C10.
Sorry, 10C10. Yes, because we are 10C10. So when you are dealing with maybe 100 features, it will be, and if we want to reduce it to 10 or maybe 20, it will be 100C20. So we have a paper on that also, that when we are dealing with this type of explosive features, then how can we reduce it? What techniques can we reduce to identify features using some heuristics, because we cannot try out all the features combinations because it would take an exponential time.
The feature means the combination of features which is at rank 1, we can say that these features or attributes have a greatest importance in the data set from Weka.
So as I mentioned, so rank 1, 2, 3 you can use, but that will not be the ideal thing. The 4, 5, 6, when they are together, they might be ideal.
When together also, when can we quote this thing that I received this result from the Weka and we can put in the paper?
That we can say.
That we can say.
But we can say.
Okay, and it will be authentic.
It will be authentic, yes.
Okay.
Because see, even in Weka, you should not mention Weka. There are some methods. So in Weka, when you are trying to do the attribute selection, there is some method like subset. There should be some principal component analysis, which then again backtracks to in PCA. You cannot do anything with the PCA features. It has to be backtracked to the inverse PCA. There should be some correlation-based things and so things. So you have to refer to that method that you have used in Weka. Just don't write the Weka. You have to.
No, that I can understand. That I can understand. But actually, the results which comes in Weka, it sometimes become difficult to understand. What does that result mean? Even if you use the feature selection, there's long line is there at the first one, and we cannot able to depict what actually that line is there, because and we do not get any good text in the Google or even in the YouTube.
Okay. So what they do is that they put out that what is the best combination they will find. So if there are say 10 features, they will list out maybe 4 features. So that is what Weka does. So just again, just
your PPT is, I think.
Yeah. So
yes, fine.
Yeah. So you can see I've just run this subset evaluation, and it gives us this. These are the select attributes. So there is no particular order. It is that these things in combination are giving this. The best.
I think you have very few attributes. That's why the problem is not there. When there is 40 attributes or 50 attributes, then
it will take some time, but it will give something out. It will give something.
But I think your result is quite loud and clear. But I think that there is a problem with version.
Version? I don't know what.
No, okay. Version of Weka.
This is version 3.
Okay,
Weka version 3.
Weka version 3. Okay.
So basically, the other simple ways is that you take 1, 2, 3, 4 the top features and slowly reduce number of features. That is starting from the all features you try to reduce. That is one way. All the alternative is you take one feature, add another feature, and go on until you go to the find a curve that where it is straightening. That is, adding more features does not increase more accuracy.
One more question I would like to ask.
Yes.
But why, when we should use Weka, or when we should use Colab, or when we should use R, or any other AI or Tableau, or when what means how I should go, which tool will be more accurate? Or
yeah, so it depends on the audience. So for example, if you are teaching students, then
as far as research is concerned,
okay. So for research, because if the data set or everything is you are entering a new domain, so then you can use Weka to get a feel of the things, because getting Python code for that and then running it will take some time to get you an understanding. But if you are already have been in the field, then Weka is not required. You can directly deep dive into the code, and because Weka is based on Java, it has some memory leak issues. So you can, although there is a way you can use deep learning for J in Weka, but it will run out of memory. So for deep learning tasks, Weka is not recommended. It is only for classical things that is recommended. Otherwise,
why Weka is not so popular as other tool, I think?
Because nowadays, apart from Python, nothing is. So it's not used in industry. That is the first thing.
Why? Can't we have a trust on Weka?
So I used this in. So I did not use that. So Weka also an API.
Okay.
So I used it in 2011. The API part of Weka, not as this visualization tool.
Okay.
So like at that time, the Python and other thing does not have so much libraries. Weka had so many ready-made algorithms to use that. So that was that. Now in Python you have scikit-learn.
So what does here students do when they do some project? What they do, they put the data set and they compare the results of the different algorithms, and they put as a project that I have done a project. And the same thing they cannot do in the Python. So is this means put the data, get the result, and things is over? Is this that means that for Weka? Means for that the Weka has been designed?
Yes. And also to get a visualization.
Okay.
The data.
Can we develop any application using Weka engine?
I actually have developed a recommendation system in 2011, but now I don't use it because Python has much meta libraries.
Okay.
And as I mentioned, there is some memory issues. So nowadays the data set size is also large. So this ERFF format, this itself blows up compared to a CSV file format. Because the data structure of Weka is made in such a way. So it's not much good. That is, if the data set is say 1 GB data, Python will still be able to handle it by making it to chunks and things. Weka cannot handle that. It will just, the machine will just shut down or get hanged. You have to, it will dump the memory heap. So for simple experiment, just to get insights, Weka is okay for academic use and showing something to the students. But for serious research in current day for data science, apart from Python, nothing else is recommended. Neither R, nor MATLAB, nor any other thing. Because all the things are available in Python.
Okay. So anyone, any query from participant side? We'll be happy to.
Dear participants, now we will close the session and see you tomorrow at 10 a.m. Thank you, everyone.